dear scientists. It's 12 o'clock and we are starting our meeting. Today, our team of moderators is working with you. And the moderators are Olga Bondarenko and Yelizaveta Stepanova from Kryvyi Rih State Pedagogical University, and Tatiana Vakaluk from Zhytomyr State Polytechnic University. Welcome to our section GSD-2023, Geography for Sustainable Development, Agroecology and Sustainable Food Systems, Geography and Sustainability, Sustainable Transport. This section is a part of conference ICSF 2023, the International Conference of Sustainable Futures, Environmental, Technological, Social and Economic Matters. ICSF is a peer-reviewed international conference which is the premier interdisciplinary forum for social scientists, life scientists, engineers, and practitioners to present their latest research results, ideas, developments, and applications. The ICSF occupies contributions in all aspects of sustainable development, focused on the intersection of sustainability, environment, and technology, and their largest implications for corporations, government, educational institutions, regions, and society both at present and in the future. But before we start, let us remind you of some rules of our cooperation. The video of our presentations are turned on only by moderators. Please turn on your microphones only during the questions. Please follow the regulations. We have 15 minutes for discussion. They include 10 minutes for presentation and 5 minutes for questions. We hope that you, as well as us, are in a safe place. If you have any questions for our speakers, you may ask them after the presentations. If you want to ask a question, you can ask it in a chat or orally, but before this, raise your hand at the bottom of your screen. And the language of our meeting is English, but if you have some problems with translations, we can help you anytime. Thank you in advance for taking part in our conference, and we are expecting a fruitful cooperation during the next 4 hours. For the 4th year in a row, in May, we are gathering from different countries to discuss the problems of sustainable development, which must fulfill the needs of the current generation without the harm for ability of future generations to fulfill their needs. And the speakers of our speakers are the first, Alexander Komlev from Faculty of Geography of Taras Shevchenko National University of Kyiv, and Olena Remezova from Institute of Geological Sciences, NAS of Ukraine. And the topic of their presentation is the Predictive and Search System of Amber, PSSA, and Sustainable Development of Mining Areas.
Good day, dear colleagues. Our collective report is the main problems of the amber branch of the economy of the Ukraine. These problems can be presented as: 1. Lack of a national program for the development of the amber industry. 2. Its insufficient level compared to the real potential. 3. Uncontrolled mining of amber. 4. Negative impact on the ecology of the natural environment. And 5. Socioeconomic consequences for the population of amber mining areas. A lack of a national program for the development of the amber industry. The national program for the development of the amber industry of Ukraine is being formed, but its structure and connections of its components are clearly visible. Forecasting such as development and exploitation and amber deposits, practical use of amber raw materials, regulatory and legal regulation, information on educational and museum and educational activities. Next problem, uncontrolled mining of amber. Uncontrolled amber mining causes the greatest damage to the state and the local population. The main reason for the rapid increases in illegal amber mining are the growth in demand for amber on the domestic and foreign markets, the possibility of mining with expensive, efficient equipment due to the presence of productive layers close to the surface, the low level of employment of the local population in the districts of Rivne, Zhytomyr, Volyn regions. Next problems, the insufficient level of development of the amber industry compared to its potential. In Ukraine, a significant database of lithological phases, paleontological stratigraphic, structural tectonic, paleogeographical, geomorphological, paleogeomorphological studies has been accumulated. It gives grounds to predict that Ukraine has perhaps the largest reserves of raw amber in Europe. According to experts, its expansion in the PAB, the main basin of the amber deposits of Ukraine, can be achieved by 1. Increasing amber production at known deposits, 2. Opening new deposits. The first way is limited by the natural and geographical conditions of the territory. The second way, the discovery of new industrial deposits of amber, is strategic and can determine the development of the amber industry in the coming years. On this slide, shows the fragments of some special maps of the territory of the North Ukraine, of the Pripyat amber basin is situated. Next problem, negative impact of the ecology of the natural environment. According to the scale of impact in the natural environment on the territory of Polessia, the illegal activity of illegals of equated to the action of spontaneous natural processes. Illegal mining of amber affects all components of the natural complex. Illegal amber mining exacerbated the problem of reclamation of disturbed lands, which is important for the organization of regional amber mining and prevention of the destruction of natural landscape. The last problem, the Finnish problem, socioeconomic consequences in number mining areas. Illegal mining of amber within the territory has revealed many shortcomings of modern social life. These are lack of an effective system of combating illegal mining use and circulation of amber in Ukraine, the invalidity of some laws regarding the protection of subsoil and the regulatory and legal support of live activities on the extraction, production and use of amber, or level on environmental education of Ukrainian citizens, primarily young people, social roots of criminal activity, employment. Next slide, finish slide is conclusion of our report. Thank you for your attention.
Dear speakers, thank you for your presentation. Colleagues, do you have any questions?
Якщо можна,
Yes, of course.
українською можна задавати питання? Так.
Yes, we'll
Да, можна,
Скажіть,
і відповідати також, да?
дякуємо вам за цікаву презентацію. Скажіть, будь ласка, які методи саме боротьби з неконтрольованим видобутком бурштину ви вважаєте найбільш оптимальними? Це перше питання. І друге питання. В Україні декілька років тому розроблялася, не концепція, а обговорювалися перспективи щодо створення туристичного бурштинового шляху. Як ви вважаєте, чи мав би він перспективність? І якщо так, то які б локації були б основними для відвідування?
Дякую for your questions. Так, я можу відповідати, да?
No, let me please translate it, and then you can... Спочатку дайте мені, будь ласка, перекласти, а потім ми відповідатимемо.
Понял.
So, what are the methods of controlling the production of amber, and what do you think about the ways of amber transportation?
One question. Change mentality, our population, в першу чергу, молодіжі. Там дуже багато можна говорити, я не буду відволікати вас. Це основний, звісно ж, економічний, соціально-економічний. І це робиться. Багато зроблено. А по другому питанню, якраз Олена Олександрівна, другий доповідач, вона цю тему дуже серйозно розробляє стосовно бурштину як туристичний продукт в такому вигляді представляти. У нас є публікацій немало і працюємо в цьому напрямку. Це, знаєте, тут дуже широкий, повен дуже, не просто там якісь там кар'єри, вириви, а взагалі, що таке бурштин? Бурштин – це сонячний камінь, це винайде від Бога. От і в цьому і дуже багато всього, і ікони, і багато чого. А сам бурштин, особливо сукциніт, я буду зараз завершу, я так вам скажу, як він утворився на стадії. Коли його, по суті, самі заготовки бурштиноподібні смоли, вони, це, як вона, господі, лімба, да? Коли рана загоюється, ви поняли, да? Лімфатична система, це лімфа дерев. Бо є факти, що по півтонни можете собі від дерева. І так воно трапилося, що коли різко помінявся клімат, палеогеографія, різко пішло море, все почало вийти, бідні дерева вони захищалися, почали виділяти. А потім далі ці заготовки бурштиноподібні тягло, і в певних умовах структура геологічна, на певних формах рельєфу йшла така флотація, знаєте, отак от. Хто золото мив, той повинен знати, да? І утворилась чудо, сувцінір, але воно від болі. От і все. І на цьому рівні це другий аспект. Там багато що може, але я особливо підкреслю. Є публікації у мене, в Оксани і деяких колег. Вибачте, я вже дуже довго говорю, я розумію, вибачаюся.
Thank you. So the answer for the first question is to change our mentality, and lots of work is done by for teenagers, especially right now. And the next question, the speaker, Alexander Komilev, has said that they have lots of different works about this topic. And the most important thing is to understand how the amber was made by nature.
Can I add something? As for controlling of amber mining, I must say about some aerocosmic methods, and we can see all diggings, all open pits, and that's why it is very important method for controlling of miners. As for amber roads, it is very interesting theme which united some aspects of history of archaeology, geology, and some interesting locations. We only began this road in Ukraine because in Poland we see very large experience, well, many museums, many locations, such as exhibitions, some amphitheaters, amber festivals, and we must make it in Ukraine. It must be a more positive image of amber in our country, and it change all situation about it. And as for location, I propose that it must be a museum, and I have an idea of some interactive museum, and I suppose that my colleagues from Zhytomyr Polytechnica can take part in it. I propose it to my colleagues, and it will be very interesting. And today we are working with some specimen to renew some landscapes of that time. It is a very difficult, very complicated task, and one of my colleagues, palynologist, is working with the specimen in Croatia. And we will continue it in Poland and in Ukraine to make very interesting panoramas of amber forest. In every country there is own amber forest, and there is in Ukraine too.
Thank you a lot for your questions and for your answers, but we have
Я
to
еще
continue.
буквально, еще можно, пани Лиза, я буквально одно предложение скажу. Просто Олена Олександрівна, Оксана, якщо можна, да. Вона основний експерт взагалі не тільки в Україні, а в Східній Європі, можна сказати, по цій тематиці. В неї не тільки знайомі науковці, але прокуратура, всякі там органи, бо вона, це, розумієте, вона людина дуже серйозна, щоб ви знали. То дякую більше. Я буквально додав до характеристики.
Okay, thank you.
Just a moment. Also, I think that it is very important plan to make to give licenses to amber mining for small companies. It is some areas about 5 or 10 hectares, and there is possibility to develop business in this depression region, such as Polisia.
Okay, thank you. And the next speaker will tell us about rational land use. So the next speaker is Dmytro Sopov from Luhansk Taras Shevchenko National University and State Biotechnological University, with the topic of his presentation, conceptual and terminological apparatus in the field of land use policy implementation at the local level.
Day. The topic of my report, conceptual and terminological apparatus in the field of land use policy implementation at the local level. An important factor in the development of any scientific theory is the formation of a clear conceptual and categorical apparatus and unambiguous interpretation of the relevant concepts and categories. Scientific research is no exception, particularly in terms of land use problems at the local level, which are on the borderline of geographical, agricultural, environmental, economic, and legal sciences. The applied nature of this area determines the peculiarities of interpreting certain scientific concepts. Together, they form the conceptual and terminological apparatus of the study. Currently, research in the field of environmental economics, and in particular the implementation of land use policy at the local level, has gained significant development in Ukraine. In view of this, the problem of improving the existing terminology in this field of knowledge is of particular relevance. Land use governance is defined by scholars as the rules, processes, and structures by which decisions are made about access to and use of land resources, the means used to implement and enforce such decisions, and the ways in which competing interests in land use are managed. OLEG is of particular relevance. The term governance can be used in several contexts, such as corporate governance, international governance, national governance, and local governance. Land governance involves decision-making, implementation, conflict resolution, and includes closely interrelated activities to manage land and natural resources for sustainable development. Land management is the process of utilizing land resources to the best effect. In this context, it is necessary to consider the paradigm of land use management. Land use management is considered through land policy, land information infrastructure, and land management functions in ensuring sustainable development. And the land use management paradigm is the cornerstone of the modern theory of land management, which defines the principles and processes that determine land management. The essence of the paradigm is that the correct construction of land use management components will allow the implementation of national land policy, and the interconnection of its elements will contribute to sustainable development. Researchers study various aspects of land use, management, and ownership, including state management of agricultural sector development, features of land use policy, improving the efficiency of agricultural land use, economic, organizational, and social aspects of land use, information support for land use, pricing in the process of forming the market turnover of agricultural land, environmental, economic, and social consequences of the transformation of land relations. A key element of land relations is agricultural land, which is the basis of the country's economic potential and plays a crucial role in the development of agricultural production and the provision of the population with the necessary food. At the same time, scientists have different views on the definition and role of land resources in the context of rapidly changing market conditions, corporatization of agricultural business, and expansion of economic activity. A person cannot create without land, because it is the material on which and with the help of which products are created, the results of his or her activity. Agricultural land has always been and remains a necessary condition and component of the process of reproduction of material values, including those not directly created in agriculture. Domestic scientists call land resources a factor of socio-economic development and the basis for the expanded reproduction of national wealth. At the same time, the issue of ensuring effective land use, ownership and disposal of land, and establishing relations between owners of agricultural land and tenants is still controversial. When formulating the main approaches to defining the category of land relations, scholars mostly use the triad of concepts: ownership, use, and disposal of land. Land relations involve the ownership and use of land as a means of production, are an element of production relations of society, and are based on the forms of ownership of land and means of production. Land relations are social relations that develop between business entities in the process of managing the land fund regarding the use, disposal, and ownership of land as an object and subject of agricultural activity. The development of land use policy implies changes in the relations between landowners, enterprises, organizations, institutions, state and local authorities, and citizens regarding the ownership, use, disposal, and management of land, subject to state regulation and promotion of scientifically sound land use. Such transformations are taking place in order to adapt to the global competitive environment and are aimed at systematically addressing existing economic, environmental, and social problems of land use. The main subjects of land relations are the owner, land user, and tenant. A component of land relations is land ownership, a form of ownership that ensures actual power over land. Ownership is an unlimited time period for a resource to belong to a certain entity, its actual dominance over the property. Land ownership has certain peculiarities related to the specifics of agricultural activities. Limited space, separation of land from the environment, close interconnection with other components of nature. Impossibility of withdrawal and transfer to another party, ability of soil cover to self-development and self-renewal as a biological system and means of production. There are various definitions of the concept of land tenure in domestic and foreign literature. In the field of land relations, this gives grounds to define land ownership as the right of the owner to carry out economic activities on the land plot and to extend his or her power to all other persons, excluding them from appropriating its useful properties. The right to property implies the freedom guaranteed by the Constitution, which consists in the possibility and ability of a person to acquire ownership of a land plot in accordance with its functional purpose in certain sizes, as well as to occupy it in the process of performing legal actions to establish boundaries on the ground in accordance with the established procedure. Thus, the definition of property rights includes two criteria: factual, the ability to have a thing under one's dominion in Roman law, and volitional awareness of the possibility and desire to dominate a thing in one's own interests. The study of these issues has been particularly intensified in the agricultural sector in the context of developing a mechanism for introducing an agricultural land market. As is well known, agricultural land can be privately state-owned and communally owned. Subjects of communal ownership of land plots are territorial communities that exercise this right directly or through local self-government bodies. The subject of state ownership of land is the state on behalf of which the relevant state authorities act. The relationship between the forms of ownership of agricultural land tends to change as a result of historical events, the formation of the political system, and the specifics of land reforms, which have their own characteristics in each country. Land use is considered to be the primary form of land relations, which gives the right to use a land plot for personal purposes and to appropriate the results of economic activity. It is defined in three aspects. First, the use of a land plot in accordance with the procedure established by law. Secondly, the use of the Unified Land Fund provided by the state or acquired in ownership or lease for economic and other needs. Thirdly, the object of economic, environmental, urban planning, agricultural, and other land relations, for which the land user has been issued a document certifying the right to a land plot with defined boundaries, area, and composition of property objects. The absence of one of these components calls into question the legality of land use. At the present stage, the land use system is characterized by functional diversity by forms of ownership, land categories, and groups of land users. Relative stability and certain dynamism, transformation of the structure of land, change of landowners and land users. Therefore, in the context of the transformation of land relations, the principles of complexity and systemicity should be met by the formation of land use systems at least three levels: national, regional, and local. The essence of this approach is to consider this problem from the general to the particular. At the same time, regional land use systems should be developed on an alternative basis as models that would serve as guidelines for choosing optimal solutions on the ground. Taking into account the direction of state policy, different forms of management, social stratification, different availability of production resources for commodity producers, and competition. Such models should compare favorably with the usual set of interrelated technological, technical, economic, social, natural restoration, and environmental measures. To do this, it is necessary to bring agricultural production processes in line with different landscape conditions and environmental laws, as well as to eliminate the causes of certain violations. The degree of adequacy of such land use models depends on the degree to which the interrelationships between the elements of the system are identified. In our opinion, the land use system should include three main subsystems: subject land users, landowners, the state, object land, land plot, technological land use itself. At the same time, each of the subsystems has its own internal structure, which consists of a number of components and determines a wide range of activities related to the use of land resources and the formation of adequate mechanisms for the implementation of the state's socio-economic policy. The efficiency of the system as a whole depends on the degree of their integration. The results of the study of the essence of the conceptual apparatus of land relations give grounds to assert that An important tool for studying the phenomenon of land use at the local level is its conceptual and terminological apparatus, which is currently in the process of formation. All the variety of concepts and terms related to the subject of research can be divided into two main groups on the one hand. These are concepts and terms from the field of land management, on the other the conceptual and terminological apparatus of land use at the local level. Land relations have an objective character and are a socio-economic and environmental process of ownership, use, and disposal of land. In connection with the establishment of a plurality of forms of land ownership, the inclusion of a certain part of land in the market circulation system in the process of concluding civil law transactions with land. These relations, while remaining essentially land, acquire a property character. The concept of land is central to the study of land use, which together with such derivative concepts as land use, land management, land cadastre, land resources, land plots, spatial forms of land use forms a conceptual and terminological system that is still being formed. Thanks for your attention.
Dear participants, let us remind you that the language of our conference is English, so please communicate in English. And now we are ready to ask some questions. So if no one has any questions, let's move to the next speaker. But before announcing the topic of the next presentation, on behalf of our organizing committee, we want to thank our guests, Volodymyr Kazakov from Kryvyi Rih State Pedagogical University and Serhiy Kobzan from Beketov National University of Urban Economy in Kharkiv, who are defending our lands and guarding our peace. Our heartfelt thanks to you, colleagues. And we are continuing, and the next speaker is Victoria Patyuk from Taras Shevchenko National University of Kyiv and Kryvyi Rih State Pedagogical University. And the topic of presentation is Mining Tourism as a Guarantee of Sustainable Development of Industrial Regions on the example of Kryvyi Rih region.
Good day, everyone. We're pleased to present the results of our research, Mining Tourism as a Guarantee of Sustainable Development of Industrial Regions, on the example of Kryvyi Rih region. Sustainable tourism is fundamentally about preserving and enhancing natural, historical, or cultural heritage, as well as promoting activities related to local identity and history. For mining regions, one of the ways to diversify their economies on a sustainable basis is to develop the tourism sector. The development of niche forms of tourism, which are fully focused on the resources of the industrial area, helps to supplement and diversify the tourist offer in these regions, including mining tourism. Our research included three important components. Firstly, identification of the place of mining tourism in the structure of tourism types and its features. Secondly, study of the resource base of Kryvyi Rih for the development of mining tourism. And finally, analyzing the possibilities and the state of use of mining facilities in Kryvyi Rih in tourism activities. The interpretation of the concept of mountain tourism in the scientific literature is not unambiguous, as scientists focus on different aspects, as shown on the slide. Having analyzed the existing approaches to the interpretation of the concept of mining tourism, we believe this tourist direction does not belong to the structure of geotourism, since in our understanding, geotourism is aimed at studying and visiting mainly natural objects, although indeed quite often geotourism and mining tourism have a common object to visit. At the same time, when the concept of mining or industrial heritage tourism is used, the attention is focused only on heritage objects. A similar situation is with post-mining tourism, where the emphasis makes on visiting transformed objects, so these subspecies absolutely exclude the production component. However, the objects of active industry are working mines, functioning mining and beneficiation plants definitely are and can be objects of mining tourism. Therefore, we defend the opinion that mining tourism is an autonomous direction that is a part of the structure of industrial tourism, which combines heritage objects, active industry and regenerated production objects. The key goals for mining tourism are presented on the slide. The Kryvyi Rih region has the best conditions for the development of mining tourism in Ukraine due to the availability of a wide range of different facilities and landscapes. In 2013, the city adopted the Industrial Tourism Development Program for 2013-2015, which was subsequently extended. However, expeditionary research of the city's mining heritage and landscapes began earlier. Back in 2004, local history work on the study of these objects was initiated by the geographer Volodymyr Kazakov, who was joined by his colleagues and students. This made it possible to create a register of mining sites in Kryvyi Rih and analyze their tourist potential for the purpose of creating excursion routes. Preparing these routes and conducting them for both citizens and guests of the city allowed us to identify the list of the most attractive objects that could become the basis for mining tours in a practical way. The criteria for selecting these sites are presented on the slide. The existing criteria made it possible to determine the key ones for tourists to visit from the entire list of objects. As experience and communication with tourists show, working quarries and mines arouse the greatest interest among visitors. And if the quarries were visited on a permanent basis, and the quarry of Southern Mining and Processing Plant was generally considered the most iconic industrial monument of the city, which is included in the European Route of Industrial Heritage Network. Then the visits to the mines took place very fragmentarily. Although the Kryvyi Rih mines are the deepest mines in Europe and their head frames are figuratively called Kryvyi Rih Eiffel Towers. In addition to the objects of the active mining industry, tour programs in Kryvyi Rih include abandoned mining objects that have formed various man-made landscapes, flooded quarries, dumps, failure zones, and other specific objects. These objects are freely accessible for tourists, and some of them could be an excellent springboard for the implementation of various revitalization projects. The advantages and disadvantages of each of the working and abandoned mining objects are presented in the tables in the article. All the authors of the study are practicing guides, so the selection of key mining tourism sites and their analysis was based on their own practical experience. Based on this, a map of the city's most attractive sites for mining tourism was created. The development of mining tourism in Kryvyi Rih has all the resource possibilities, but the presence of a powerful resource is not a guarantee of effective tourism. Before this resource is consolidated into a quality tourist production, it must be brought to the proper level. For this, we offer the concept of 3R: reclamation, revitalization, rethinking. This concept is described in more detail in the text of the article. Thank you all for your attention. We hope that you will not only read more about our research, but also visit the impressive mining facilities of our city.
Thank you for such an interesting presentation. And now we are ready to ask you some questions.
I have a question, please.
Okay, you can ask.
Мене чуть, Вікторія? Чуть. Гаразд. Оскільки наша секція має назву, принаймні пов'язана із сталим розвитком, доповіді цей термін прозвучав у контексті сталий туризм, так? Я правильно зрозумів? Було таке?
Yes, of course.
такий термін був. От мене цікавить, з точки зору феномена сталості, в його початковому розумінні, в розумінні концепції сталого розвитку ще Ріо 92-го року. Сталий розвиток – це такий, який дає можливість жити сучасним поколінням і, ну, скажімо так, забезпечує ресурсами майбутнє покоління. Яким боком, яким чином туризм пов'язаний ось з цим принципом? От мені це самому просто цікаво. Ви, напевно, як докторантка, повинні були вже розібратися у цій проблемі. Дякую.
So the question is, in context of phenomena of scale development, how is the tourism connected with the scale development?
Дякую за запитання. Чесно кажучи, доволі складно відповідати англійською, тому буду відповідати все ж таки на рідній мові. Звісно, що ми в даній статті поняття сталості трактували все ж таки через призму саме розвитку туризму. Хоча загальновідома це концепція трьох складових: економіка, суспільство та природа. І, власне, от саме той напрям туризму, який ми розглядали, гірничий туризм, він передбачає те, що зрозуміло, що основа це безпосередньо розвиток господарства, який, безумовно, дуже негативно вплинув на екологічну ситуацію. Однак, як показує досвід багатьох країн світу, які вже перейшли в стадію такого постіндустріального розвитку, навіть маючи такі депресивні і трансформовані ландшафти, однак їх можна переставляти на ну, так би мовити, на рейки сталого розвитку в контексті того, що ми можемо їх використовувати саме з акцентом на те, з одного боку, щоб показувати, як людина негативно вплинула на ландшафт, і таким чином формувати виховний такий вплив, що цього, можливо, треба не робити, або щось робити в більш такому лояльному плані. З іншого боку, ми можемо ті трансформовані ландшафти все ж таки робити їх більш екологічними і більш придатними для використання соціуму в майбутньому. Тобто, так як, наприклад, в розвинутих європейських країнах відпрацьовані гірничо-промислові ландшафти, вони трансформуються в рекреаційні зони, в різноманітні такі еколого-просвітницькі проекти, де ми, маючи певний ландшафт, ми його використовуємо саме з екологічною метою.
Дякую, я задоволений.
So when we use all this landscape in the case of development of household, we can use it like showing the negative impact on these unecological stuff, and also we can transform them into more ecological ones, like in Europe people do. And also we have another question from Olena Hanchuk. Kryvyi Rih, which you had been researching for some time, had a status of a frontline city, and our mining properties are unlikely used as a touristic in view of current security situation. Does Kryvyi Rih have any prospects of attracting foreign tourists in the context of development of this tourist destination?
Mm-hmm. Thank you for your question. Of course, the war in 2022 stopped any tourism activities in our city, but we hope that the war will end, and our visit and our country will be visited many European citizens, and not only European citizens, and our city will as destination where people will came and to see the influence of Russian aggression, and за виключенням
On the exception of
of war tourism, we can propose industrial and mining tourism, because we have this 10 landscape that in other European countries not представлены in these scales, because in the presentation was information that in Kryvyi Rih we have the deepest mines, the biggest dams, and other type of landscapes.
Thank you for answering all the questions. And now let's move to the next speaker. In the conception of sustainable development, the 16th goal is peace, justice, and strong institutions. And the next presentation is about the problem of war and peace. And the speakers are Svetlana Mantulenko from Kryvyi Rih State Pedagogical University. And the topic of presentation is Assessment of Military Destruction in Ukraine and its Consequences using Remote Sensing.
Assessment of military destruction in Ukraine and its consequences using remote sensing. Here you can see the representation of all authors and co-authors of article, and we are going on to get deeper into the context. So, as a result of a full-scale war, more than 30% of the territory of Ukraine suffered war pollution, destruction, bombing, and etc. In just half a year of war confirmed by the World Bank, the number of losses caused by Russia's military aggression amounts to more than $340 billion. To get a compensation from the aggressor country, it's necessary to
Unfortunately, we have some technical problems. Excuse us for a second.
Measure and confirm all the destructions. One of the most successful ways to manage it is to use the Earth remote sensing technologies. Aerospace images gives the independent and exact evidence, which are the result from the deciphering the data of the DZZ. It is significant that this baseline data set shows current and operational situation in the damaged area, and it helps also to decrease uncertainty of the damage characteristics of the ground and make it more certain. The purpose of the work is to explore the possibilities of using Earth remote sensing methods in the zones of armed conflicts for the investigation and evaluation of the consequences impact on the geographical environment and economy of the state. For making the research, it was necessary to use different time satellite, panchromatic, and multispectral images with different resolutions. The main sources of images are open platforms such as FIRMS, EO Browser, Google Earth Pro, USGS Earth Explorer, and Maxar technologies. It is important that all the sources of the images are official and can give the independent and accurate evidence gained through the decoding of satellite images. Image processing has been done in the Open Quantum GAIS environment. Earth remote sensing data visualize a variety of environmental damage, but also should be taken into account that this is a visual monitoring method, and it can be used only to assess exclusively visually recognized and evaluated damages. So from all the environmental damage caused by hostilities, the following can be studied with the help of data of ERS. For example, degradation of land resources, destruction of natural ecosystem by fires, and destruction of structures, buildings, and constructions. So let's go through each of the examples separately. Satellite images with a very high spatial resolution led us to estimate the level of damage in the surface soil layer. On satellite images of the Donetsk region taken during the military invasion, we can see agricultural fields covered with hundreds of artillery shells. Funnels of such density almost completely destroyed the soil cover and make it not usable. There are 71 crates from explosions on an agricultural field near the city of Liman in Donetsk region, with an area of 0.06 square kilometers. Using ERS data, it is possible to calculate that almost 200,000 pieces of metal with a total weight of about 2.5 tons fell into the soil in a certain area of the field with an area of 0.06 square kilometers. These metal fragments are dangerous, and in addition to iron and carbon, they also contain sulfur and copper. And considering the number of projectiles and their caliber, it's possible to calculate the total amount of chemicals in the environment in the explored area. So this is about like 35 kilograms of carbon, 32 kilograms of sulfur, and 16 kilograms of copper. And the destruction of the soil cover and other negative factors makes the territories of rural lands unsuitable for use. And it takes like hundreds of years to renew land resources from pollutions. And monitoring of fire areas is one of the most common types of practical use of data from ERS. And for a detailed analysis of fires and their consequences, it's necessary to use satellites with the resolution of less than 30 meters, such as Landsat 8, Sentinel-2A, 2B, and etc. And among all natural ecosystems of Ukraine, forests suffer from hostilities the most. The massive use of artillery and strike aircraft against military and infrastructure facilities in or near forests causes fires, which destroy tens and sometimes like hundreds of square kilometers of forests. Mapping the destructive effects of wildfires is the most effective in the shortwave infrared range. For the Sentinel-2A satellite, this is a combination of channels B12, B8A, B04. And in this composite, we can see the vegetation in shades of green and like recently burned land in shades of brown. To record and calculate the consequences of forest fires, it's necessary to have two pictures from different times, before and after the fire. And in this way, we can get accurate, objective, and reliable evidences. And we can obtain also the necessary combination of channels for capturing the analyzed terrain from using the EO browser cloud platform. And the functionality of the platform allows us to measure the area of destroyed forests using polygons. And for semi-automated methods of calculating the area of forest destroyed by fires, it's also possible to process a raster image in the environment of a geoinformational system. And in Figure 6, we have an example of raster classification of a satellite image of the Nedogorsky forest in the QGIS program. The consequences of agricultural land fires are recorded in the same way, and as a result of Russian challenge in Ukraine, fires were recorded on almost 8,000 square kilometers of agricultural land, with crops of various farming cultures in just 6 months of the war. To document the effects of fires, it's necessary to get the information from the public reports from citizens, also the government or the local authorities. Or we have other options. We can get it from based on the fixation of some source of ignition from satellite images of low spatial resolution, such as Terra Modis. And then we need to get images of medium spatial resolution, such as Landsat 8 and Sentinel-2A and 2B, and determine the area of the fire in the shortwave infrared range. And the table shows examples of calculations of areas with crops in Zaporizhia and Kherson regions. And it should be noted that forest and steppe fires destroy the fertile soil layer, and along with it, millions of microorganisms that keep the natural balance of the environment just die. And the number of animal and plant populations is also significantly decreasing. And the determination of the catastrophic consequences of these destructions and estimation of the economic losses is possible only by conducting spatial research on the area. One of the most significant indicators of the destructive actions of the Russian army in Ukraine is the ruining of civilian and military infrastructure. And according to official data, Ukrinform, during 300 days of the war, the occupiers destroyed at least 412 industrial enterprises, more than 15,000 high-rise buildings, 116 116,000 private houses, almost 1,000 medical facilities, 511 administrative buildings. And for each of these facts, it's necessary to form an evidentiary base, and the areas becomes here quite important. And to study the destruction of structures and constructions, it's necessary to use only satellite images with a very high spatial resolutions. And this picture makes it possible to compare the condition of buildings before and after the damage. And due to the deciphering of the pictures, it's possible to access the condition of building damage. And it is also important that the analysis of satellite images with a very high spatial resolution guarantees the diagnosis of the state of the building in 3 levels of disruption, like completely destroyed, partially destroyed, or destroyed. In future, in order to safekeeping, quick search, analysis and visualization of all useful information, it's necessary to digitize it in the GIS environment. And with the help of GIS functionality on the raster image of the satellite photo, we can recognize destroyed objects, classify their types, and determine the level of ruination. And these objects are digitized with the separate vector layers considering of their types and level of destruction. And in this way, the information is analyzed and saved. And coming to the conclusions, we would like to point that, first of all, aerial images are a unique form of evidence of military destruction, and the information obtained with their help shows an operational situation in the destruction zone, helping to make it more certain and more clear. Sources of satellite images are official state or commercial structures, which are in easy public access. And this provides also the accuracy of the gained evidence for trials and lawsuits against the aggressor country. The deciphering of the data of remote sensing of the Earth makes it possible to get a clear assessment of environmental damage according to the following indicators, such as degradation of land resources, destruction of natural ecosystem by fires, and the destruction of buildings and constructions. And the last conclusion is that the proposed methodology for assessing military destruction is simple, accurate, and versatile, and doesn't require any expensive equipment. Thank you for the attention.
Dear speakers, thank you for your presentation. Colleagues, do you have any questions?
Так, будь ласка, можна запитання? Скажіть, будь ласка, а чи є досвід використання даних дистанційного зондування Землі для оцінки збитків від конфліктів воєнних, які б робили міжнародні організації? Прошу вибачення українською.
Excuse me, do you have any information of distance zondation of all the destroyed things for foreign people?
Yep. Hello. I'm so sorry, for the quality of presentation. I don't know what caused it, but anyway, today there are some couple examples of using the Earth remote sensing data to assess damages from military conflicts by international organizations, and this is mostly United Nations. This is also the World Bank and Amnesty International and etc. And now since 2003, the United Nations Satellite Center, for example, UNOSAT, it provides analysis of satellite images during humanitarian emergencies, related to natural disasters, also complex emergencies and military conflicts. So as an example, we can also cite that the results of damages assessment of buildings in Kherson in Ukraine, which are based on images received from Worldview 3 satellite, and analysis of images taken on October 14, 2022, can reveal us that we have 88 damaged buildings there. And it's also possible to cite as an example that of using of remote sensing data to study the development of the crisis and refugee flows, for example, after the Arab Spring. And through the analysis of Landsat 8 satellite imagery, like in 2013 and 2015, like Salha like determined the impact of population growth and also the Syrian refugee settlements on the rangeland of degradation in Jordan.
Thank you.
Thank you. And what are the perspectives of your other maybe destinations?
Okay. Earth's remote sensing data like visualizes like a variety, like big variety of environmental damage, and like, but at the same time, it should be like also remembered that it's like a visual monitoring method, and it can be like used only to assess like those damages which can be like visually recognized and evaluated like using only images like from different spectrum ranges and the corresponding spatial like resolution. Yeah, and of all damages to the environment, we can study like easily by this way is the degradation of land resources, destruction of natural ecosystem, and by fires, and also like the destruction of buildings. So like also as an evidence database, like the Earth remote sensing data may be not enough still, because in this case, like all this obtained data must be supplemented with additional information, like from verified sources, like for example, survey at the site of destruction, or like we need to use also images from unnamed aerial machines.
Thank you for all your questions and answers. And let's move to the next speaker. The 21st century is the century of responsible consumption for the sake of sustainable development. And one of varieties of sustainable development is presented by the next speaker, Olena Hanchuk from Kryvyi Rih State Pedagogical University. And the topic of the study is characteristics of BlaBlaCar as one of the world's ride-sharing leaders.
Characteristics of BlaBlaCar as one of the world's ride-sharing leaders. Within the scope of this publication, we aim to examine the characteristics of BlaBlaCar as one of the world's ride-sharing leaders, to consider its advantages and disadvantages, to envision the prospects for its development. The digitalization of society and rapid development of information technologies have led to the emergence of sharing economy. It prioritized timely access to goods and services over ownership, shifting from hyperconsumption to joint consumption. This responsible model of consumption promotes sustainable development. Rachel Boastman, a well-known propagandist of the sharing economy, convincingly responded a question why humanity should move to a more coherent and responsible consumer culture. In her speech at the TED conference back in 2010, she highlighted the inefficiency of individual ownership. She proposed sharing tools and equipment through borrowing, lending, or leasing, which optimizes resource utilization and reduces costs. Carpooling came into being in the USA and the countries of Western Europe in the 40s of the 20th century, and with the advent of the Internet, it received an impetus for the development. According to Modern Intelligence, the ride-sharing market will continue to grow rapidly due to the increasing demand for economical and time-saving vehicles, and by 2027, it will grow by 18%. The European region presently demonstrates the largest carpooling market, although the Asia-Pacific region shows the signs of even faster growth. BlaBlaCar is a leading example of the sharing economy, specifically in the shared ride market. It operates as a carpooling information network, allowing drivers to save on gas expenses and passengers to travel at a lower cost compared to public transportation, rail, or air fares. With over 100 million users, BlaBlaCar serves as an online platform and cloud data storage, facilitating effective search for travel companions and providing monitoring services to prevent fraud. The service is available in 22 countries worldwide. We can distinguish three stages of the BlaBlaCar development presented in slide. The emergence of BlaBlaCar, 2006 to 2010. The idea originated in 2004 when Fred Mazzelli wanted to find a driver to share fuel costs for a trip. In 2006, he purchased the codevoyage.fr domain and co-founded the project with Fred Nepson, Nicolas Brusson, and Olivier Bonnet. The product development strategy was formulated during this stage. The second, development of BlaBlaCar and its entry into the European market of shared trips, 2011-2014. BlaBlaCar expanded into the European market using different websites, such as Commuta in Spain. In 2011, the company entered the UK market and changed its name to BlaBlaCar based on users' indicated talkativeness levels during registration. In 2012, BlaBlaCar further expanded into 6 European countries and standardized its network by renaming the Spanish and French sites. The company received significant investments from Insight Venture Partners and LeadEdge Capital, becoming one of the most Europe's valuable startups. The third, new markets extension, new product offers, 2014 to 2023. BlaBlaCar expanded into Turkey in 2014 and India in 2015. In 2015, it also entered the Latin American market, specifically Mexico and Brazil, with a $200 million funding round. Since 2019, BlaBlaCar has included a legal bus carrier service called BlaBlaCar Pro, connecting carriers and bus fleet owners with nearly 100 million users. In 2018, BlaBlaCar diversified its offerings by acquiring OEBus, a French bus operator, and later partnered with Bus4, a leading bus ticket service in Ukraine and Eastern Europe. The company also launched the BlaBlaHelp app in April 2020 to assist with purchasing products or medicines during the global COVID-19 pandemic. The findings merged from the data analysis can identify the following generalized characteristics of BlaBlaCar users. Majority of users, 62%, are males, with fewer females due to safety concerns. BlaBlaCar offers a girls-only option to address this. The diversity in age with a predomination, more than half making 43% of young users aged 25 to 34, people aged 35 make up 30% of users. This can be explained by the fact that this age group are the most advanced users of social networks, the main consumers of goods and services of the sharing economy. BlaBlaCar enables people with special needs to use network sites by changing interface settings, zoom, and navigation using the keyboard. Our research reveals behavioral traits of BlaBlaCar users worldwide. Although there are no significant differences in user behavior across countries, some distinctions exist due to the cultural customs and mentality. Regarding trip planning, users in Western, Southern, and Northern European countries typically plan a shared trip a week or two in advance. They confirm trip details and check the driver's profile 2 or 3 days before departures. In Central and Eastern Europe, trip planning occurs 2 to 3 days in advance, with less emphasis on detailed driver profile checks. Latin American users may plan a trip a week ahead, but frequently cancel it 2 or 3 days before. Driver profile checks are less comprehensive in this region. The countries of the Asian region, users strictly observe customs and traditions peculiar to Oriental culture. Thus, women in India, for example, ride only with a female driver. The gender of the user determines the thoroughness of detail checking in the driver's profile. BlaBlaCar entered the Ukrainian market in February 2014 due to the takeover of Podorozhniki. As of 2023, Ukraine is among the top 3 countries where BlaBlaCar is developing rapidly. The Ukrainian market boasts 8 million users, with 1 million using the platform monthly. The Ukrainian office employs around 100 people. Analysis of data from the official website indicates that 55% of users utilize BlaBlaCar for vacation trips, 49% for visiting family or relatives, and 42% for business travel. Passenger traffic trends to increase before holidays, with popular destinations in Ukraine, including summer resort cities like Berdyansk, Kirilivka, Iron Port, Zatoka, and South. For winter, popular regions are Bukovel, Vorokhta, Yaremche, and so on and so forth. However, due to the full-scale invasion of Russia into Ukraine, these summer destinations are no longer relevant. The COVID-19 pandemic and the Russian-Ukrainian war have impacted BlaBlaCar's development in Ukraine. In March 2020, BlaBlaCar requested users to temporarily halt travel and advised using the platform only for exceptional and urgent trips. Following the government's decision to ban passenger transportation, BlaBlaCar suspended all bus trips, including those on the Bus4 platform. Currently, the Ukrainian government is gradually allowing the restoration of long-distance travel. BlaBlaCar has implemented improvements and new features on its platform to promote necessary safety measures and health precautions. Users are reminded of safety recommendations and such as not driving if experience COVID symptoms, wearing a mask, maintaining distance, etc. In April 2020, BlaBlaCar launched BlaBlaHelp, a free application for buying essentials during the COVID-19 pandemic. Over 35,000 users have utilized it, and the company encouraged users to share the application with those in need. Additionally, BlaBlaCar supports the armed forces of Ukraine by providing quick and free trips for military personnel needing transportation to this destination. To conclude, the salient features of the BlaBlaCar Information Network are: BlaBlaCar Information Network is a part of the sharing economy, which is developing at a fast pace. The network provides users with wide possibilities to make trips. The network differs from traditional types of logistics systems. Some aspects of BlaBlaCar activities are partly non-commercial, international, global, and informal. Users can travel in any direction and at any time, and so on and so forth. Considering the features listed above, we can distinguish the main advantages and disadvantages of BlaBlaCar. They are represented on the slide. Sharing economy in general and ride-sharing in particular groups in financial benefit, time and resources saving, rational consumption, trust, and communication technologies. Nowadays, BlaBlaCar is a new model and a vivid example of the economy of shared and responsible consumption. It is one of the world-leading online sharing platforms which has gone a long path from the idea of finding fellow travelers to mastering the global market of shared trips and offering new products. Thank you for your attention.
So, dear speakers, thank you for your presentation. And colleagues, do you have any questions?
I have a question. You consider BlaBlaCar as a segment of the ride-sharing economy. So, what is ride-sharing?
Дякую за запитання. Зрозуміла його, але з вашого дозволу відповім українською мовою. Я думаю, що, можливо, всі знають уже, що шеринг – це економіка спільного користування, і дійсно в сучасному світі вона дуже розвивається швидкими темпами. Сьогодні можна сказати, що вона доповнюється новими функціями, новими можливостями. Також ми можемо стверджувати сьогодні, що шерингова економіка – це, мабуть, один із таких сучасних трендів, і саме він формує сьогодні таку нову модель споживання. І можна говорити також, що ця шерінгова економіка, вона сьогодні створює такі нові зв'язки між людьми, і ці зв'язки навіть пов'язують дуже на великій відстані дає, і це дає поштовх для того, щоб утворюються нові такі шерингові інтернет-платформи. І прикладом, наприклад, сьогодні економіки спільного користування, шерингової економіки, ми, мабуть, з вами сьогодні вже всі його бачили, і йшовши по вулиці, ми з вами бачимо, що будь-де може стояти електросамокат, так? І ми можемо до нього підійти, Якщо нам потрібно під'їхати, головне, щоб був додаток в мобільному телефоні, і таким чином можна говорити, що ми сьогодні можемо скористатися такою послугою. Тобто це і є, по суті, шеринг, да, економіка спільного користування. Якщо говорити про поняття, як ви говорите, райдшерінг, то в перекладі райд – це поїздка, шеринг – спільна, тобто те, що ми якраз і говорили про BlaBlaCar, що водій і попутчик шукають один одного для того, щоб зекономити на подорожі. І, можливо, я б хотіла тут, говорячи про шеринг, райдшеринг, от сказати такі 3 основні моменти або 3 основні принципи шерінгової економіки, які якраз і можуть стосуватися BlaBlaCar в тому числі. Це перший такий принцип, який притримується, це не використовуєш, отже, втрачаєш. І от говорячи про BlaBlaCar, що ми можемо сказати? Що це якраз цей принцип, він дозволяє водіям отримувати вигоду за рахунок того, що за рахунок пасажирів, яким з ним по дорозі. Потім і ще один із принципів шерингової економіки – не обов'язково володіти, щоб використовувати. Що ми сьогодні бачимо? Дивіться, що сучасна молодь, вона більше притримується, надає, навіть не притримується, а надає перевагу не стільки новій покупці, а для того, що може орендувати цю річ. І тому вони якось більш спокійніше, більш мобільніші вони, і вони спокійно відносяться до того, що вони переходять з одного місця в інше, переїжджають, і таким чином вони користуються речами. І третій принцип, який також підходить, це довіра золотом. Це те, що процеси глобалізації, вони дають таку можливість, завдяки процесам глобалізації люди, вони стали ближчими один до одного, вони почали більше довіряти одне одному, і тому от якраз економіка спільного користування, цей шерінг, райдшерінг, він дає поштовх для розвитку. Маю надію, що відповіла на ваше запитання.
So the sharing is the economy of common use. And it makes our networks among people, it makes it a trend. And the example which we can see in everyday life is electro-scooter. It can be used in any place and by anyone. And also it is important to emphasize the 3 principles of sharing economy. They are, if you don't use, you will lose. If you don't have it, it doesn't mean that you can't use it. And that principle, it increases our mobility. And also the principle of trust, which is quite popular among young people nowadays too. And we have another question from Victoria Patyuk. You're welcome.
Yeah. What do you think about the future perspectives for the development of BlaBlaCar in our country?
Що ви про розвиток цієї технології BlaBlaCar у майбутньому і у теперішньому?
У нашій країні.
Якщо говорити про перспективи, досліджуючи дану тематику, хочемо сказати, що, по суті, ми мали такий, знаєте, обмежений доступ до статистичної інформації, і так, щоб прям глобально говорити про проблеми і перспективи, але в будь-якому випадку ми намагалися досліджувати, дуже так детально до всього підійшли, і ми можемо стверджувати про те, що наше дослідження показало, що перспективи розвитку існують BlaBlaCar, і в першу чергу це при дослідженні ми з'ясували, що в першу чергу це буде стосуватися те, що будуть освоюватися нові ринки. Не дивлячись на те, що сьогодні європейський ринок є якби найбільшим, найширшим, все ж таки в перспективі ми вбачаємо, що розвиватися буде цей азіатський регіон, перспективи має Австралія, Північна Африка, також і ще одним із перспективних напрямків ми вбачаємо це те, що буде вже насичення вже існуючих ринків, тобто, що це мається на увазі? Ну, будуть використовуватися нові види транспорту, такі як автобуси, і по суті вони зараз вже, в принципі, активно починаються використовуватися, так? Це будуть використовуватися спільні перевезення вантажними автомобілями, так? Тобто це такі, ми б сказали так, що ми вбачаємо сьогодні два такі основні напрямки, перспективні, і вони стосуються, ну, не тільки, якщо говорити, ну, України, да, і України в тому числі, я б сказала, тобто це якби загалом. Ну і, звичайно, одним із перспективних напрямків, який також сьогодні запроваджується, це упровадження монетизації. Тому, ну, от, в принципі, ми вважаємо, тобто наша група, яка досліджувала дану проблематику, вважає, що перспективи розвитку Блаблакару, вони існують. Ну, єдине, що трошечки, да, от, колеги мої додадуть, можливо, ковід, війна трошечки дали такий, ну, скажімо, мінуси, да, але з іншого боку перспективи має. Ну, колеги мої можуть доповнити, будь ласка, дякую.
Я трохи доповню, оскільки була автором цієї статті, і я скажу так, I will say the question in answer in Ukrainian and Lisa will translate it. Thank you. Значить, сьогодні прозвучало про те, що сталий розвиток – це розвиток, який задовольняє потреби нинішнього покоління без шкоди для можливості майбутніх поколінь задовольняти свої власні потреби. За цими шеринговими технологіями я вважаю, що майбутнє, тому що 21 століття – це століття відповідального споживання, а відповідальне споживання – це 12-та мета сталого розвитку. Чому відповідальне споживання? Тому що сьогодні ми на слайді наводимо приклад Ботсван Рейчел, яка сказала про те, що коли ми купуємо дрель чи купуємо, наприклад, те ж авто, коли купуємо дрель, то по факту платимо гроші, використовуємо 12-13 хвилин за весь час її експлуатації. Коли купуємо в середньому за $8000 авто, то використовуємо, тобто 23 години на день воно простує і у сумі десь годину ми ним користуємося. Сьогодні не важливо мати річ, сьогодні важливо мати доступ до неї, тому я думаю, що на сьогодні суспільство загалом усвідомило важливість взагалі збереження довкілля, збереження цього сталого розвитку. І по факту ми бачимо, що навіть у нашому місті говорила Олена Вікторівна про те, що певні технології використовуються, коли просто надається доступ. Тому, в принципі, зрозуміла річ, що суспільні виклики будуть впливати на такі явища суспільні, як той ковід чи та війна, але тим не менше майбутнє за шеринговою економікою.
Okay, so there are some perspectives, and they are new markets, which are which are broadened, especially in Asia, Australia, North Africa. Also, new transport, such as buses or freight transportation, and also the monetization. Nevertheless, we have COVID or war. These perspectives, these ways are continuing to develop. And also the future depends on them. And as Rachel Bowen said, if we buy a car, we can use it only 1 hour. So it is not a rational use of money and of our time, which affects economy, ecology, and other stuff.
Ще доповню, скажу якби останнє, да, що дійсно перехід до економіки спільного споживання – це дійсно ключ до сталого розвитку, який буде задовольняти потреби нинішнього покоління без шкоди для можливості майбутніх поколінь. Ну, така якби ремарка. Дякуємо.
Thank you for your answers. And also we have another question. Do you plan to pursue your studies in this way further? Чи ви плануєте продовжувати займатися цією проблемою далі?
Так, дивіться, ця проблема нас дуже цікавить, якщо чесно, і у нас є велике бажання займатися даною проблемою надалі. Ми декілька разів зверталися до компанії офіційної компанії в Україні для того, щоб вони нам надали якісь статистичні дані, щоб проаналізувати більш детально. Нам самим було цікаво, особливо коли ми досліджували регіональні особливості. Ну, на жаль, скажімо так, вони нам давали ту інформацію, яка, як правило, наявна в інтернеті. Чому вони її таку давали? Ну, можливо, вони її самі не ведуть таку статистику, яку ми хотіли, а можливо, вони вважають це комерційною таємницею, я б сказала так. Да? У нас є така думка після цієї конференції надати їм свої дослідження, і, можливо, після цього вони будуть до нас більш відкритішими. Тобто у нас є бажання, да? Але ми хочемо, щоб більш детальніше нам потрібна інформація, якої, на жаль, ми поки що немає в нас її. Маємо надію.
Okay, so for them, it is very interesting, and we want to continue our studies. And there were lots of attempts for asking for some statistics for the company about all the stuff. And the company actually gave us that statistics, but these statistics is everywhere in the internet. So the plan is such, maybe to send this study to the company and show them that there are lots of possibilities, and if they just give us some statistics to continue our researches. So do you have any more questions? So there is no one and no questions. So let's move to the next speaker. And the problematics of rational usage of natural sources will be continued by another speakers. Sili from Ternopil, Volodymyr Hnatyuk National Pedagogical University, and Natalia Panteleva from Kryvyi Rih State Pedagogical University. And the topic of presentation is the problem of rational use of mineral resources and mining waste in the context of sustainable development of regions.
Dear colleagues, our research involves consideration of the problem of rational use of mineral resources and mining waste in the context of sustainable development of regions. Ukrainian enterprises generate up to 100 million tons of toxic waste every year, of which more than 3 million tons belong to first or third hazard classes. The total amount of toxic waste accumulation is 4.4 billion tons. In Ukraine, there is no plan for their processing of toxic industrial waste or landfills for their disposal. The conditions of waste storage and disposal do not meet sanitary and hygienic requirements and are one of the factors of intense pollution of atmospheric air, surface, groundwater and soil. It is also worth mentioning the illegal shipment of 25,000 tons of acid tars into Lviv region. The problem of their disposal has not been resolved by today. In the developed countries of the world, a considerable attention is paid to the issue of effective use of mining waste, and the level of their utilization is 65 to 80%. In Ukraine, this indicator is estimated to be only 10 to 12%. Therefore, we have accumulated unused reserves of secondary mineral raw materials. Rational use and protection of the subsoil is an integral part of rational nature management within the mining areas. Rational nature management should be understood not merely as the optimization of the process of intensive use of natural resources and their protection, but also as a system of measures covering the issues of environmental protection and control, reproduction and preservation of these resources, effective use of capital investments in mining enterprises, the distribution of the productive forces of the region. From the general issue of rational nature management in the region, one can single out the rational use of mineral resources. Equally important components of the latter are comprehensive development of mineral deposits, comprehensive use of mineral raw materials and mining waste, optimization of the structure of mining production and mineral raw materials consumption. The optimal use of mineral resources includes, on the one hand, the most detailed study of deposits at the stage of exploration, pre-exploration and exploitation, the choice of rational scheme for the most complete extraction of useful components during mining enrichment and processing, and on the other hand, requirements for the comprehensive use of mineral raw materials, the methods and means of extracting minerals, which are used in modern technologies, do not solve the issue of their complete extraction from the subsoil. The resulting losses sometimes exceed the volume of actual production. Particularly significant losses are recorded in the underground method of development. A quarry method, as a rule, can reduce the loss of raw materials by 3 to 8%. For the sustainable development of Ukraine, it is necessary not only to develop new reserves of natural raw materials, but also to develop technogenic mineral resources accumulated in more than 1,600 technogenic deposits and objects. Technogenic deposits contain non-ferrous, rare, noble, ferrous, metals, rare earth elements, non-ore constructions and energy raw materials, limestone and gypsum, etc. These components can be removed using the latest technologies. The simplest technological option remains the organization of waste disposal for the production of building materials. A list of construction materials, magnesium and sulfur containing fertilizers, limestone and gypsum meliorants can be compiled from mineral raw materials waste in Ukraine. It is also possible to additionally obtain coal fuel, ferrous, non-ferrous, rare metals and fluxes from industrial waste, which is important in conditions of acute shortage of raw materials. The development of technogenic deposits in Ukraine makes it possible to expand the mineral base of the mining industry by 15 to 20%. Up to 30% of overburden and host rocks removed from the subsoil, as well as waste from their enrichment, can be used for the production of building materials. The waste of primary processing of raw materials is various sand and sand clay sludge. The volumes of this waste in the regions of Ukraine are measured in hundreds of millions of tons. For example, in Kryvyi Rih area, reserves of sludge from the enrichment of iron ores exceed 1 billion tons. Waste from secondary processing of raw materials is accumulated in significant quantities at enterprises of various metallurgy enterprises, thermal power industry, chemical, petrochemical industries, etc. Often the content of mining waste in such elements as copper, cobalt, zinc and others makes them suitable for the use in agriculture as agronomic ores. The density of accumulated waste in Ukraine is 6.5 times higher than in the US and 3.2 times higher than in the countries of the European Union. Every year more mining waste accumulates in Ukraine than in 12 European countries. Donetsk, Dnipropetrovsk, Lugansk, Lviv and Zaporizhia regions should be singled out. In the densely populated areas of Donbas, Kryvyi, Prednipro and Precarpathian regions, the level of technogenic load ranges from 3 to 30 million tons per kilometer square. Table 3 shows the volumes of technogenic waste accumulate within the main mining basins of Ukraine, which account for 79.2% of the total amount of waste. The problem of effective use of hydromineral raw materials is important. It is possible to extract industrial quantities of lithium, boron, germanium, etc. from underground mine waters. For example, the underground waters of Donbas contain from 0.152 to 0.355 of bromine, which exceeds the minimum industrial value of bromine by 20 to 60 times, germanium by 5 to 8 times, and lithium by 2 times. It is necessary to continue studying the distribution of useful elements and components in mine waters and developing technologies for their extraction. Radioactive waste burial grounds should also be considered as deposits of technogenic raw materials. With a higher level of technological development, they can serve as a source for the extraction and enrichment of radioactive elements. The main mass of disposed mining waste is used for backfilling spent quarry areas and mine sites, reclamation of disturbed lands. In the backfilling process, not only waste rock is used, but also industrial waste, which can be processed into useful products. However, the technical level of extraction and use of these wastes is insufficient to establish their rational use. In the main mining regions of Ukraine, there are thousands of technogenic mineral deposits that are preliminarily prepared for processing, which will significantly reduce the cost of their development. According to some estimates, with modern technologies, about 40% of industrial waste can be used to obtain useful raw materials, commercial coal, ore concentrates, cement, building materials, chemical meliorations, etc. The Geological Service of Ukraine registered 1,500 industrial waste accumulation sites. Among them, only 13 sites have the status of technogenic deposits. The rest are tentatively classified as potential deposits or technogenic manifestations. According to the amendments to the legislation in the field of waste management, the number of industrial technogenic deposits may reach 200 or 300. Effective use of technogenic mineral raw materials will ensure, first, reduction of cost for the search of new and exploration of explored mineral deposits, second, preservation of non-renewable mineral raw materials, extension of the life of mining enterprises, third, production of additional volumes of cheap precious metals, non-metallic and construction materials, etc. Fourth, filling of mine and quarry mine sites, planning of post-mining landscapes, carrying out reclamation and revitalization. Fifth, reduction of anthropogenetic load on disturbed territories. Sixth, release and rational use of land occupied by mining waste storage facilities, elimination of source of pollution of the natural environment. Seventh, attraction of investments and improvements of equipment and raw material processing technology. The use of energy and resource-saving technologies in the mining sector will improve the environmental situation in Ukraine. The latest technologies are proved to be effective within a short period of time and ensure the maximum output of the final product per unit of raw mineral. The cost of commercial products from mining waste is 5 to 15 times lower than from ores extracted by traditional methods from natural mineral deposits. Solving the problems of rational use of mineral raw materials is also related to the development and implementation of waste-free technologies. Today, the development of man-made waste in production process is restrained by the low economic capacity of the state. The accumulation of significant amounts of mining waste in Ukraine is a consequence of the irrational use of certain useful components. Under the condition of comprehensive use of mineral resources, the amount of waste will be reduced by 2 times. Such comprehensive use allows to increase the amount of obtained industrial raw materials and is of a great economic importance. The reform and development of the mining industry should be based on principles that meet modern economic and environmental requirements. The development of technogenic deposits in Ukraine would expand the resource base of mining and metallurgical, coal and mining chemical industries by 15 to 20%. Up to 30% of extracted overburden and associated rocks as well as waste from their beneficiation can be utilized for the production of various building materials. The comprehensive utilization of mineral resources can only be achieved through the development and implementation of advanced modern technologies in areas of exploration, extraction, enrichment, and processing of raw materials. In general, solving the problem of rational use of mineral resources as well as natural resources in general is related to the development and implementation of waste-free technologies. A geological assessment of waste as technogenic deposits is also necessary. Only after carrying out a complex of such assessment works should the issue of waste and methods of waste utilization in specific territories be addressed. Priority should be given to environmental protection measures accompanying current mining industrial production. The main factors that have influenced the economic development of Ukraine based on intensive and prolonged use of mineral resources include first, gradual depletion of subsoil, second, the formation of an economy skewed towards heavy industries, and third, the accumulation of long-term negative ecological consequences. Further development of Ukraine's mineral and raw material complex requires urgent resolution of state-level problems that significantly hinder the expansion of the mineral and the raw material base, its ecological rehabilitation and rational use. The current system of subsoil use in Ukraine does not meet the requirements of modern market economics, and there are no unified requirements or rules for subsoil use and determination of payments for their use in economic theory. Although Ukraine's mineral and raw materials base has sufficient reserves of many types of valuable minerals, some of them are in the stage of depletion, which requires reform of the economic and ecological mechanism for using mineral resources. In strategic terms, it is important for Ukraine to determine the directions of movement in the field of geological exploration and subsoil use. Thanks for your time.
So thank you a lot for an interesting presentation, and we are ready to ask some questions.
Скажіть, будь ласка, можна, так? Я знову українською. Скажіть, будь ласка, так як же будемо вирішувати проблему утилізації відходів?
So how will we resolve the problem of utilization?
Дякую за запитання. Ми розглядали в нашому дослідженні шляхи ефективного вирішення питання утилізації відходів, яке полягає передусім. Зрозуміло, що нагромаджені відходи ми повинні переглянути з точки зору можливостей їх утилізації. Яким чином? Перш за все, зміни підходів повинні бути до вирішення питань використання відходів, тобто підбір нових технологій до вже наявної сировини. Впроваджені ці новітні технології переробки відходів в промислову продукцію саме з нової точки зору. Оцінити потреби необхідно наявних споживачів і зрозуміти, наскільки ми можемо замінити традиційну природну сировину техногенною, мінеральною сировиною, скажімо так. Окрім того, виробництво продукції з відходів у порівнянні з затратами на використання традиційної сировини, також воно буде трішки дешевше. Окрім того, визначені економічні показники, вони повинні розглядатися ще з точки зору транспортування, тобто прийнятих відстаней для транспортування відходів чи продуктів їх переробки. Оцінити природоохоронну ефективність використання відходів від підприємств, які їх виготовляють, у ці відходи, до підприємств, які є підприємствами-утилізаторами. Зрозуміло, що і треба оцінювати затрати на складування, на захоронення даних відходів. Використані відходи ми також повинні розглянути з точки зору цінних компонентів з метою заміни дефіцитної імпортної сировини на ту, яка є в наявності в Україні. Окрім того, ще повинен бути правовий механізм регулювання цього процесу, тобто впроваджені економічні стимули, пільги. Для чого? Для того, щоб можна було збільшити обсяг переробки промислових відходів і розширення асортименту вже готової продукції. А також в нас все ж таки не вистачає законодавчих, правових, податкових умов комплексного використання саме техногенних відходів. Думаю, що я на ваше питання відповіла.
Thank you. So the ways of utilization, we can firstly think if we can utilize the waste. We can use for this some new technologies, and of course think more about how to implement them into everyday life. And also think how we can replace some out-of-date technologies and maybe how we can replace the way of utilization of waste. And also, it is a great idea to make some production from wasted products and think more and maybe do some more researches about transportation of waste, about the distances on which we can transport that waste, and also think more about the effectiveness of utilization, because in some cases it is not effective at all. And also think more how we can use the waste, these technologies, instead of the technologies abroad, and instead of the maybe other stuff abroad. And also there must be some economical help, some benefits for those who utilize the waste. So are there any more questions?
Так, Семки, дякую.
Okay, and also we have one more question from Olena Hanchuk. What is the current state of use of man-made mineral sources in Ukraine and how can they be used? Який стан використання техногенної мінеральної сировини зараз в Україні та яким чином можна її використовувати?
Дякую за запитання. Ми живемо з вами, я про всяк випадок, і більше з вас, це гірничо-промислові регіони, да? В яких є десятки великих і малих техногенних родовищ корисних копалин. Якщо брати Геологічну службу України, на обліку стояло приблизно 1600 таких техногенних родовищ та об'єктів, скажімо так, нагромадження промислових відходів. Чому? Тому що саме із цієї великої кількості, 1600, тільки 13 об'єктів нагромадження є в статусі техногенного родовища. Інші умовно зараховано до категорії потенційних родовищ або техногенних проявів. І згідно з поправками до законодавства в сфері поводження з відходами, кількість промислових техногенних родовищ в принципі може збільшитись до 200-300 таких одиниць. Зрозуміло, що на сьогодні лабораторно-аналітичне вивчення техногенних родовищ, воно проведено більш ніж на 1200 підприємствах різних галузей. Це і Запорізький титано-магнієвий комбінат, і Миколаївський гліноземний завод, і Кримський титан, да? Це ще зрозуміло, що раніше було проводилось. І наші криворізькі хвостосховища також були переоцінені з точки зору вмісту корисної речовини. Зрозуміло, що найпростішим технологічним варіантом зараз в Україні це залишається організація утилізації відходів з метою виробництва будівельної сировини. Тобто з відходів мінеральної сировини в Українах можна скласти значний перелік саме будівельних матеріалів або певної частини, наприклад, мінеральних відходів, мінеральних добрив, наприклад, або інших компонентів стосовно саме будівельної сировини. Наприклад, взяти знов-таки Кривий Ріг, да, відходи залізно-рудної промисловості, це використовуються відходи для будівництва дамб, гребель, насипів, доріг, а також для виробництва і гранульованого шлаку, тобто хвости збагачення залізної руди ми можемо вживати також як вторинну сировину для виробництва знов-таки будівельних матеріалів. Тобто відходи ми можемо використовувати з метою вилучення саме корисних компонентів. Ну, поки що ми використовуємо більшість як будівельне сировино, як засипаємо кар'єри, засипаємо різні вироботки. Поки що ось таким чином використовуємо, на жаль. Хоча перспектив дуже велика, скажімо так, перелік цих питань. Це ми також в подальшому будемо розглядати в своїх дослідженнях.
So we live in regions with really developed mining industry, and also the main clue is like the organization of utilization resources for materials, especially for building. For example, in Kryvyi Rih, all these resources are used for building some dams or roads and other things. And unfortunately, nowadays, that is the only way of usage of these utilized resources.
Може, ще колеги щось хочуть додати, тому що присутні, а то я одна відповідаю.
Lisa, please read the question from the chat.
Okay, so we understand how difficult it is to get access to statistics today. Tell me, please, how did you manage to do this? Ми розуміємо, як складно зараз знайти справжню статистику. І поділіться, будь ласка, як вам вдалося зробити це?
Більшість статистичної інформації збиралася ще до початку війни, коли сайт в нас GeoInform був відкритий і у вільному доступі була ця інформація. Там була інтерактивна карта, яка показувала родовища, стан її запасів та інше. Окрім того, там були і інші статистичні дані, які були у вільному доступі. На жаль, зараз ця інформація закрита, але її надають, скажімо так, по запиту за гроші. Тобто можна купити дану інформацію у GeoInform за запитом, офіційним запитом.
So the biggest part of statistics was gathered before the war, when all the websites were in access for everyone. But now, during the war, it is possible to buy this access, maybe to write to some people who have this information and have it.
Thank you very much.
So thank you for all your questions and answers, and we move to the next speaker. The next speaker is Natalia Dotsenko from Mykolaiv National Agrarian University, and the topic of presentation is investigation of constructive and technological parameters of an energy-efficient screw oil press.
And technological parameters of an energy-efficient screw oil press. At the current stage of economic evolution, in the conditions of the need to transfer the state's economy to an intensive path of development, the most rational use of production potentials is an urgent problem. One of the main tasks of sustainable food systems is the implementation of new technologies for the processing of agricultural products in the conditions of enterprises and farms, as well as the production of small-sized, low energy-consuming equipment for completing technological lines. All known types of screw presses can be divided into three groups: presses for preliminary and final removal of oil, and double-acting presses. The geometric parameters of the oil presses, the kinematic and energy indicator, are determined by the physical and mechanical properties of the oil-containing seeds. Oil presses that are used in the conditions of farms that process small volumes of sunflower have a number of disadvantages: low yield of oil in one pass, increased time spent on cleaning the press from clogging, which contributes to a significant decrease in the productivity and demands to manually push the oil cake from the hopper into the receiving and preparation chamber. On the basis of the investigation of theoretical provisions of the process of oil separation by pressing sunflower seeds and engineering calculating methods, it is proposed the constructive and technological parameters of an energy-efficient screw oil press. There was a theoretically justified methods of calculating the constructive and technological parameters of the screw press conducted the factor ranking. The insignificant factors were excluded from the further consideration. In the investigation, we used the methods of generalization of theoretical and laboratory experimental studies, mathematical modeling of the process, substantiation of the method of processing experimental data, solution of the optimization problem in determining the constructive and technological parameters of an energy-efficient oil screw press. The material is fed into the receiving hopper, which is crushed by the refilled rolls. The gap between the rollers is regulated depending on the physical and mechanical properties of material. In the hopper, the sunflower pulp is subjected to moisture and thermal treatment with steam. The yield of the oil increases. After the moisture and thermal treatment, through the loading hole regulated by the valve, the material is sent to the middle of reception and preparation chamber, where it is captured by the turns of the screw shaft and moves to the exit. Depending on the state of the pressing material, the pressure in the working chamber is regulated using the adjustable knob. Steam generator consists of a steam atomizer, heat exchanger, turbo electric heater, expansion tank, hydro groups. The use of steam generating device in the design of screw press will contribute to the intensification of oil separation to increase its yield and will extend the service life of the structural elements of the machine. The purpose of the research was to check the technological reliability as well as quality indicators of the technological processes according to 3 optimization criteria: maximum oil yield, minimum energy consumption, and maximum press productivity. There is presented a ranking diagram of factors that affect on quality of work. The most important are the length of the reception and preparation chamber, the material moisture, the heating temperature, the screw rotation speed, the linear speed of movement of screw shaft turns. According to the two-dimensional intersection of response surfaces, the zone of optimal combination of factors is limited by the arcs of the oil yield, energy consumption, and press productivity curves. The yield of the oil will be in the range of 45–50%, the energy consumption not exceed 59 kilowatts, and the press productivity will increase to 260 kilograms per hour. The analysis of the results of experiment demonstrates the high quality of indicators of the technological process when the length of the reception and preparation chamber is 560 millimeters. It is possible to achieve an oil yield up to 50% with an equipment power 55–60 kilowatts and productivity of 260 kilograms per hour. Humidity in the range of from 9 to 15% promotes better oil separation. In order to achieve better values of the quality indicators of the technological process compared to the 2 previously considered options, it is necessary that the length of the reception and preparation chamber be increased by 280 millimeters. As a result, it will be obtained more qualitatively crushed mass, and the pressing temperature is in the range from 105 to 130 degrees. The selected combination of factors corresponds to the figure limited by the shaded area. The curves of oil yield is 50%, energy consumption 55 kilowatts, and press productivity 260 kilograms per hour. The special feature of the design of screw oil press is that the steam atomizer is installed in the receiving hopper under the refill rolls for carrying out moisture and thermal treatment. The energy consumption of the pressing process is mainly influenced by the independent factors: the length of the reception and preparation chamber, the material moisture, the heating temperature, the screw rotation speed, the linear speed of movement of screw shaft turns. The purpose of research is to check quality indicators of the technological process according to the optimization criteria: oil yield, energy consumption, and press productivity. The most profitable constructional and technological parameters of the screw press have been established, namely, the length of the reception and preparation chamber is 560 millimeters, the moisture content of the pulp is within from 9 to 15%, and the pressing temperature is 130 degrees. At the same time, the yield of oil is from 45 to 50%. Thank you for your attention.
Thank you for your presentation. And dear colleagues, if you have any questions, you may ask them. Katerina Mantulenko, please.
Yeah, I have a question. Thank you so much for the presentation. So my question is like, what factors influence the principle of operation of an energy efficient screw oil press, and also like the extraction of oil from sunflower pulp? If it's necessary, I can translate into Ukrainian.
Мікрофон включіть.
Включіть, будь ласка, мікрофон, вас не чути.
Мене не чутно було? Зараз чутно нормально?
Зараз вас чути.
Добре, okay. Thank you for the presentation again. So trying to say again my question. So my question is, what factors influence the principle of operation of an energy efficient screw oil press, and also like the extraction of oil from sunflower pulp? Was it clear now?
Наталя Доценко, будь ласка, вімкніть мікрофон, нам вас не чути.
Oh, yeah, do you hear me? Oh, okay. Thank you for your question. So there was chosen 12 factors, and from these 12 factors, then according to its ranking, were chosen 5 most important factors. It is the length of the reception and preparation chamber, the material moisture, the heating temperature, the screw rotation speed, and the linear speed of movement of screw shaft turns. And so, according to these factors, were made the improvement of the construction of the oil screw press. And it was made according to the optimization criteria. To the optimization criteria were intended the oil yield, the energy consumption, and the press productivity.
Okay, thank you for the answer.
Thank you.
Thank you. And also we have one more question. What difficulties did you encounter during your research?
Difficulties. I think the most difficulties were to make the experiment, so that's a pity, but at the moment I can't present you the experimental installation because it exists at the basis of the laboratory of the Mykolaiv National Agrarian University. At its basis were made all the experimental investigations, but at the moment I cannot show it because we don't have access to our laboratories because of the situation. But I think the main difficulties it was to make experiment to push the installation, and then so them and to collect all the data.
Thank you a lot for your questions and for the answers. And we move to the next speaker. The next presentation is about very actual for Ukraine topic and which has a real practical meaning. So it is called Geospatial Modeling of the Location of Bomb Shelters in Residential Areas of the City. And the presenters are Yelena Pomortseva and Serhiy Kobzan from Beketov National University of Urban Economy in Kharkiv.
Добрий день.
I'm Sergey Kovzin from Beketov.
Презентацію видно, перший слайд?
Yes.
The title of my article is Geospatial Modeling of the Location of Bomb Shelters in Residential Areas of the City. And I would like to tell you about determining the optimal placement of the bomb shelters in the existing and development. The author set the task of processing topographic and geometric data and related information. The authors implement the task employing spatial analysis using existing administrative data and related information. The authors implement the task employing spatial analysis using existing administrative software models. The use of the information system in the article makes it possible to spread the speed of information processing than when using traditional methods. The use of the geoinformation system by the authors allows the creation of geodatabase with all the necessary attributive information. The intellectual analysis of the existing information was created in this work using the geostatistical method to data transformation from the degrees of the continuous representation. Thus, we will determine the future of our object of research. There are almost all buildings have many floors. The houses are close to each other. There are no undeveloped areas on the territory. Buildings with a small number of floors are located randomly and in small numbers. The author solves the problem in the article of determining the location of bomb shelters in the existing urban development. The object of the study is a typical district. Special analysis. There are no real data on the number of people living today. The population was calculated according to the formula on slide 4. Means use to implement the research result in the article. The geoinformation system is allowed to create a detailed visualization and conduct a high-quality spatial analysis of the location of the bomb shelter with reference to the territory. Creating a digital map. The article created a personal geodatabase with the necessary layers. USC 2007 coordinate system was set for all layers. The initial data for vectorization as the material of the general plan of the city of Kharkiv. Determinant of area where the debris of the building threw. In the article to mark the dangerous zone, the distance of the whole debris around of building was calculated. You can see result on slide 6. Determining the location of the bomb shelter The location of the bomb shelters are made on the digital map with dots, slide 7. The authors propose to create 3 bomb shelters with 2,500 places in each. Not all of the bomb shelters will fall into the area where the debris of the building flew, and entrance to them will not be blocked for the public. The shelters are locked next to each other. The population will be able to quickly move to another shelter. Determination of optimal rules to the bomb shelter. According to the security regulation, people need to move the 15 minutes to reach the bomb shelter during danger. The article finds optimal rules to each part of the neighborhoods and determines the time of people moments. The employment of roads, the article 2 authors need the network analysis model of the RG's geoinformation system. And another slide. On this slide, you can see the algorithm of finding of optimal place of the location of the bomb shelters and about results. In the author's development of digital geoinformation model of 5 to 2 microdistrict with the introduction of the significant amount of attribute data. The optimal rules to the design bomb shelters we calculated using geographic information system and the plane of the digital map. In the article calculated a map regarding the distance of debris flying around building and dangerous zone displaying of the digital map. After development, an algorithm for finding the optimal place of the location of the bomb shelter. And conclusion. Thus, the geoinformation modeling used by the authors made it possible to carry out actions to determine the optimal location of the protected structure of the population. The application of the geoinformation technologies for modeling the optimal placement of bomb shelters in the city made it possible to consider many factors. That is, the author proposed how to solve the problem with minimal time of error probability. The article calculated the space for the construction of bomb shelters to the civilian population in the 5 to 2 microdistrict of Kharkiv, using spatial analysis carried out on RGs. The digital information model of 5 to 2 microdistrict of Kharkiv has been developed. In general, the intelligent analysis, the geostatic model can be used to process data in any locality sense to the use of geostatistic method to transform data from the decrease to the continuing representation. And thank you for your attention. Glory to Ukraine. Slava Ukraini.
Героям слава.
Thank you for your presentation. And now, if somebody has any questions, you can ask them.
May I ask my question by Ukraine because more understanding all colleagues. Доповідь дуже цікава, оскільки ми з моїми колегами представляємо велику географічну науку і, власне, геопросторові моделі – це також наша спеціалізація. Ну, ваша доповідь викликала запитання, тому що вона є актуальною, на жаль, через наслідки воєнних дій. Я хотів би задати вам таке запитання концептуальне. Ізраїль має набагато меншу територію, ніж Україна. Тому у архітектурних рішеннях вони змушені приймати, ну, вірніше, ухвалювати такі рішення, як, наприклад, спеціально захищена кімната у кожній будові. Там, ну, переважно середньоповерхова забудова. Тобто при об'явленні будь-якої повітряної тривоги, погрози ракетного обстрілу, люди переходять туди. Ну, в одній з публікацій робив таку пропозицію. Якщо нам іти шляхом дезурбанізації, тобто скупчення у одному місці великої кількості поверхової забудови, елементів інфраструктури, насправді, ну, дуже небезпечне з точки зору забезпечення життєдіяльності, якщо все це поступово розосереджувати по території України. Дякую.
Ну, ми виходили, можна вже відповідати, да, чи ще ні?
Let me please translate it and then you can answer. So Israel has a smaller territory than Ukraine, and in every building there is a special place which is quite safe, and if there is an air alert, people go there immediately. So if we think about desurbanization, so having less people in one place, less buildings in one place, can it be real in our situation?
Ну, тоді відповім на ваше питання, буду відповідати українською мовою, і вибачення не буду за це просити. Те, що ви кажете, це, як кажуть, в ідеалі. Питання в тому, а що робити тим людям, які вже живуть в тих районах, де йде багатоповерхова забудова, де вона вже є. І я якраз і мешкаю ось в цьому багатоповерховому районі Салтівки, міста Харкова. Ось. І тому ми вирішували те питання, яке було насущне на той момент, навесні минулого року. Виходячи з ДБНів, державних будівельних норм, було за допомогою геоінформаційних систем винайдено територію, на яку, ну, у разі влучання снарядів можуть розлітатися осколки багатоповерхової будівлі, виходячи з того кілька поверхів в тій чи іншій будівлі, і було винайдено найнебезпечніше місце в нашому районі. Ну, це я, як вам доповідаю, ті моменти, які стосовно касаються нашого об'єкту дослідження. А головне – це ось ця схема, на наш погляд. Як підходити до винайдення місця, де повинно бути збудоване сховище, в тих районах, які вже мають багатоповерхову забудову. Тобто відселяти людей, ну, наразі, як кажуть, дай Боже, щоб ми відбудували те, що порушено. Це вже наступне питання. Якими будуть нові райони? І підемо ми, це в ідеалі, по тій дорозі, якою пішов Ізраїль. Да, це гарно, це в ідеалі. Наше завдання було вирішити те, що ми маємо. Ну і ми свій підхід вирішення цього завдання якраз і на ваш розсуд і предоставили.
Тоді я перепрошую, на додаток до мого запитання. Я сам 15 років прожив у Харкові, у мене там є родичі, які живуть саме на Північній Салтівці. Ну, спочатку серйозних військових дій, які ви позначили там весною 22-го року, з тих будинків виїхало ну понад 60%, це точно. І найприкріше те, що сьогодні повернулись не більше 30 з тих, хто виїхав. І найприкріше те, що вони не збираються повертатись. Тобто та ідеальна модель, яку я окреслив, вона не така вже ідеальна. Насправді ця дезурбанізація, хай ми назвемо її еміграцією, тимчасовою або постійною, вона поступово проторює собі шлях.
Я не зовсім тоді зрозуміла, в чому постає ваше питання.
Питання полягає в тому, чи варто, скажімо так, якісь серйозні сховища, вони оптимальні і, скажімо так, їх варто впроваджувати, але стосовно кількості от таких сховищ на великі житлові квартали, ну тут ще треба досліджувати.
Ну, я свою відповідь розіб'ю на дві частини. По-перше, я впевнена, що варто це робити, тому що навіть 30% людей, які на Північній Салтівці, а ще є Салтівка звичайна, дуже великий район, їм треба десь переховуватися, коли небезпека стає. Тому, а в ті часи, коли це часи Радянського Союзу, коли будувалися ці багатоповерхівки, це питання зовсім не вирішувалося. Тобто вирішити його треба. Ось це нами запропоновано один з підходів до вирішення цього питання. Ну, а друга частина вашого питання, повернуться люди чи не повернуться, ну, це будемо так казати, ну, по-перше, в наше дослідження зовсім не входило, і це такі і політичні питання, і тому давайте ми їх і зовсім торкатися не будемо.
Дякую.
Okay, thank you. And also we have the last question from Mr. Nazimko, please.
Доброго дня. Професор Назимко, Інститут фізики гірничих процесів. Хочу відмітити, що доповідь дуже актуальна. І автори пропонують самий короткий шлях, скажімо так, мінімальними засобами досягнути максимальних результатів. Тільки можна підтримати. Щодо концепції, то, наприклад, Ілон Маск, ми підтримуємо цю ідею, він пропонує у зв'язку з збільшенням людства активніше застосовувати підземний простір. Тобто робити багато рівневі підземні тунелі, сховища, ну, може не житло, але дуже, так сказати, опановувати підземний простір. Так що тут багато може бути концепцій. І щодо війни, наприклад, зараз експоненційно збільшуються так звані офшорні вітряні, ну, скажімо, фабрики електроенергії. Це великі, дуже великі вітряки на плавучих таких базах, які причеплені до дна за допомогою ланцюгів потужних. Вони виробляють дуже ефективну електроенергію. Але якщо хлопцям з Росії захочеться просто пальнути по них, то всі ці енергетичні установки просто розваляться. Тут питання філософське, не тільки технічне, не тільки, але й філософське, на жаль. Що не роби, а якщо дур є, то можна розбити. Не треба багато розуму, щоб побити.
Ви абсолютно праві, тому що це останній обстріл будинку в Умані, де я зараз мешкаю, от все порушилось, починаючи з підвального приміщення. І, ну, власне кажучи, ну, підземні сховища так само не врятували людей. Так, ви абсолютно праві, да. Треба боротися з цими хлопцями. Да, дякую.
Доповідь я підтримую, дуже раціональне, дуже правильне рішення. Поточне. Дякую.
Thank you for all your questions.
Дякую за питання.
and answers. And let's move to the next speaker. And the next speaker is presented by Dmitro Gupti from State Biotechnological University. And the topic of the presentation is the use of GIS technologies for geodetic monitoring.
My name is Dmitro Gupti. I am an associate professor of the Department of Land Management, Geodesy and Cadastre of State Biotechnological University, and I would like to make a presentation which prepared with my colleagues from State Biotechnological University, Vytautas Magnus University, Lviv National Environmental University, and the topic of our presentation is the use of GIS technologies for geodetic monitoring. One of the directions of modern applied geodesy is deformation monitoring. This concept includes geodetic monitoring for subsidence and deformation of foundations, as well as other important structural elements of buildings and structures. In addition to them, various industrial equipment can be objects of deformation monitoring. Deformation geodetic monitoring consists in regular tracking of deformation of building and other important structure by geodetic methods carried out with the aim of timely direction and prevention of the development of emergency situations. This type of engineering monitoring is an important link in the construction as well as the system of state and department technical supervision. On 26th of April 1986, the largest man-made disaster in the history of mankind occurred, the explosion at the Chernobyl nuclear power plant. In a short time, from June to November 1986, a protective structure was erected over the destroyed force power unit of the Chernobyl nuclear power plant to protect the environment from further pollution. Today, this structure is known as shelter. Since the shelter facility was built within a short period and under extreme conditions, it does not comply with the rules and regulation for the design, construction, commissioning, and operation of either nuclear installation or radioactive waste management facilities or regular industrial buildings. Therefore, after its construction, the constant engineering and geodetic monitoring of the state of the entire complex of buildings and structure of the shelter facility became the key task. In addition to natural wear and tear, man-made factors also affect buildings' structure. Mechanical impact, abrasion, fatigue with repeating changing loads, corrosion of metal parts, structures, and elements, erosion, weathering of stone and concrete structures, etc. The mechanism and intensity of action of these processes are different. The degree of influence of the factors of each specific case may vary in intensity, but in each case, the main factor in extending the life of the building is the timely detection of the main damage and the defects of the building, as a result of which they are eliminated. The volume of engineering and geodetic observation of the shelter facility includes the regular determination of the high position of the settlement control marks on the foundation and the special position of the deformation marks located respectively in the plinths and on the upper tiers of the shelter facility. The sign installed on the foundation of building are placed on the transfer and longitudinal axis of at least 4 signs around the perimeter. They are installed on the end walls of the shelter facility according to the assembly diagram. In the place of temperature seams on both sides of them, control marks are installed. Observation at the point are performed in group of 4-5 direction to eliminate errors of focus change during one reception of observation due to a different distance and errors of closing the horizon. Angular measurements are carried out by high precision tachometers. Angles and lines are measured by the method of tunnel triangulation of the 1T discharge and tunnel trilateration of the 1T discharge, respectively. Processing of the results is carried out using the Kryvyi software complex, which allows performing in-camera processing of traditional geodetic measurements and post-processing results of satellite measurements of various accuracy classes in the selected coordinate system, with the possibility of considering the geoid model and a complex of reduction corrections. Moreover, various geodetic constructions are performed in the system. The Kryvyi software product allows importing data from field measurements obtained from electronic tachometers within accepted formats. After entering the initial data and importing the measurement, the Kryvyi system automatically recognizes and separates the data by types of measurements and form the network connection. The system preprocesses the measurements, calculates, considers the necessity, correction, and reduction, and calculates the preliminary coordinates of the points. Vector direction intersect to form a triangle of measurement error from different survey points under the same observation coordinate conditions. At the intersection point of the medians in the center of the observation point, where the coordinates of the x and y point are determined. Then the obtained results are entered into the table of observation according to the circle the geodetic monitoring was carried out. The use of GIS technologies allows for fast data processing, reduce the workload of the employee, and make it impossible to make mistakes during data processing and analysis. Since the beginning of the observation, the horizontal movement of 10 control marks of the northern wall of the shelter facility amount to 28 millimeters on average with the northern direction of the vector. The mark M18 has a maximum horizontal movement 34 millimeters from the beginning of observation. The average horizontal movement of the control marks M16 and 20 of the northwest corner from the beginning of the observation are 31 millimeter with the northern direction of the vector. At the same time, the maximum values of horizontal movement are 33 millimeters, the mark 16. The average horizontal movement of control marks M4 and the pin of the roof of the central hall from the beginning of observation is 19 millimeters with the northern direction of the vector. The maximum values of horizontal movement are 24 millimeters, mark 4. The control marks of the tower along the Z row received average horizontal movement from the beginning of the observation 8 millimeters with the north-west direction of the vector, and the marks of the P row got respectively 9 millimeters with the west direction of the vector. The control marks of beam B1 and B2 in row Z and P received average horizontal movement of 5 millimeters and 7 millimeters from the beginning of observation. Control marks M50Z and M50P on the wall axis 50 have received horizontal displacement of 5 millimeters and 13 millimeters from the initial observation. The horizontal displacement of the new control marks of the southern wall of the machine hall in row A from marks M302 to M312 during the observation period range from 2 millimeters to 10 millimeters. The horizontal displacement of this control mark on the western wall of the machine hall on axis 68 mark M301 has become 6 millimeters since the beginning of the observation. Analysis of the magnitude of horizontal and vertical displacement of control marks includes that the process of deformation is taking place in the object and adjacent building and structures. Conclusion. The analysis of the horizontal and vertical movement of the control marks shows that the deformation process of the shelter object and its adjacent building and structure continues. For the analysis of movement of control marks over a year, operational limits of safe operation are established. Since geodetic measurements are equalized between observations some season over a year with minor fluctuation in measurements temperature. The obtained results will be used as input data for tracking the dynamics of movement, the stability of building structure, and taking timely measures to prevent the destruction of structure and forecasting emergency of the shelter facility as well as the adjacent buildings and structure. The values of movement of the control marks of the structure of the northern cascade wall for the annual period between the season observation of the same name do not exceed the permissible parameters of movement established by regular documents. The use of GIS technologies allow for fast data processing, reduce the workload on the employee, and makes it impossible to make mistakes during data processing and analysis. With the help of the Kryvyi software complex, the processing of the result of geodetic surveying of monitoring points reduces the time boundary, which allows for a more in-depth analysis of deformation process, which in turn makes it possible to timely identify critical indicators, if any, during data analysis. This concludes my report. Thank you for your attention.
Dear speakers, thank you for your presentation. And colleagues, if you have any questions, you may ask them. So, you presented the results of the annual monitoring of the shelter deformation. In general, is this geodetic monitoring annual or long-term? Ви презентували результати річного моніторингу деформації укриття. Загалом, це геодезичний моніторинг, він річний чи багаторічний?
Hello everyone, thank you for your question, and we think that according that shelter is very important object, and the impact of radiation is very high. We think that we must do annual monitoring of a shelter, because we can see that there is some deformation of the structure. Yes, they are not so big, but it's quite quite reasonable, yes, and we think that we must do annual monitoring.
Okay, thank you for your answer, and we have another question from Mr. Nezinko, please.
It seems that horizontal component of displacement tends to approximately 0-degree azimuth. What is the reason? What is the reason?
Sorry, I don't understand the question. What is? Can you...
Тренд горизонтальної компоненти переміщень схоже знаходиться приблизно в напрямку, в нульовому напрямку азімута. Яка причина в цьому? Яка фізика? На малюнку знизу вверх.
I see, but unfortunately, I didn't take part in measurement, and in measurement in this measurement participated Mitrochanos, but unfortunately, because of yesterday missile attack, he hasn't an electricity and hasn't the possibility to came to this conference. And of course, I think he knows this question better and deeper, and it's better that he answers that question, because I don't explain this situation.
I see. Thank you.
Okay, thank you for such a discussion, and we move to the next speaker. The next presentation is about a methodology of sustainable development, and the presenter is Sergei Sonko from Uman National University of Horticulture, and the topic of the presentation is Geographical Foundations of the Sustainable Development Concept, the Paradigmatic Level.
Good day, our colleague. Name of our report, Geographical Foundations of the Sustainable Development Concept, the Paradigmatic Level. During the 30 years of existence of Sustainable Development Concept, a global environmental problem, the solution of which it was aimed at has not been solved but continues to worsen. The authors chose an integrative approach to solving the ecological problem based on the typological principles of the foundation of spatial socio-natural system. This is what caused the authors to reach the paradigmatic level. The concept of the noospheric lies in the field of correct foundation of the global environmental problem. The primary spatial unit of noospherogenesis is not civilization, but a modified human ecosystem or an agroecosystem, the evolution of which leads to the formation of other noospheric ecosystem, urban ecosystem, and infra-ecosystem. In this scheme, we can see a formation of noospheric ecosystem with main etaps. An agroecosystem is an ecosystem that combines the anthropic and social nature of man. The agroecosystem ensures the removal of inert matter taken from nature from the organismic level to the level of joint consumption by the entire population. As a result of the existing spatial dynamic of Homo sapiens, the information influence of urban ecosystem hinterlands on the surrounding space is gradually increasing thanks to the means and tools of the information infrastructure which is where the name infra-ecosystems actually comes from. At the same time, the highest level of information influence which leads to an increase in planetary entropy is inherent to today's so-called world cities. At the early stages of the formation of the modified human ecosystem, agroecosystem, the greatest attention was paid to the actual food extraction. As the second stage, cities' urban ecosystem becomes the main centers of the information influence around which hinterlands gravity zones gradually from which leads to a gradual squeezing of geographical space. The third stage, modern, is associated with the acquisition of the highest level of informational density by urban ecosystems and the transformation of some of them walled cities into infra-ecosystem. At the same time, the global entropy occurs the highest degree. At the fourth stage, the most development infra-ecosystem pull up other types of nospheric ecosystem to their level. The next stage of the formation of a modified human ecosystem will begin, space when cosmo-ecosystem begin to form. In our opinion, the compression of geographical space must necessarily be compensated by real time. For such compensation, a person creates time traps as if putting it on the time by which its development. For a constructive solution to the global ecological problem, it is necessary to find such areas of space in which the difference in the speed of nature and society is reflected, and in the future, gradually reducing them, bring them to optimal ratios. In order to search for negative segment of space, the spatial dynamic of agroecosystem formed on the territory of the Kharkiv region were investigated. The study of agroecosystem made it possible to draw a conclusion about the simulations existence of two types of borders, the dynamics of which go beyond two-dimensional understanding. According to modern ideas, such non-coincidence leads to an increase in the level of planetary entropy and therefore to information tension, which most likely is the cause of the emergence of not only environmental but also many other global problems. The above analysis was carried out in the context of the modern spatio-temporal paradigm. The lack of an interpretation of the category of information entropy, negentropy, in it also explains, in our opinion, the impossibility of correctly posing an environmental problem. It is from this that the general logic and stage sequence of the development of the new information space-time paradigm originates. Conclusions. The construction of a geographical picture of the world in the context of the information spatial temporal paradigm allows modification of the main theoretical foundations of modern geography, as well as a new look at the structuring and awareness of the global environmental problem. Hopelessness in its solution comes from an incorrect definition of methodological guidelines in the study of the main foundation of the interaction of nature and society, and it derived from this erroneous understanding of the phase sustainable development. The methodological uncertainty of the very idea of sustainable development prompts the interpretation of this idea precisely taking into account the geographical picture of the world in the context of the informational spatial time paradigm. Thank you very much.
Okay, thank you for such an interesting presentation. And we are ready to ask some questions. Svetlana Mantulenko, please.
Вас не чуть, мікрофон включіть.
Перепрошую, доброго дня. Скажіть, будь ласка, ви у своїй статті зазначаєте, що просторова парадигма, яка тривалий час існує в географії, потребує вдосконалення, поглиблення. Питання в чому? В чому ви вбачаєте вдосконалення просторової парадигми і як оптимально організувати простір, щоб вирішити екологічні проблеми?
Ну, в принципі, про це, як туди ще і часову компоненту. Ну, по-перше, це відповідає абсолютно усім напрацюванням в природничих науках. По-друге, на прикладі дослідження типології сільського господарства Харківської області, а це ми продовжуємо зараз на території Черкаської області, ми довели, що будь-які, я б сказав би, не трансформація, а спотворення, далекі від оптимізації географічного простору, вони повинні компенсуватись часом. Тобто суспільство якимсь чином випереджає природу, тому, власне, виникають екологічні проблеми. Але природа включає свої механізми компенсації. Для того, щоб уникнути цих проблем, необхідно шукати оці ділянки простору, на які не збігається оптимальна конфігурація, зокрема кордонів агроекосистем, і приводити їх у відповідність. Чим доведено? І ще, працюючи над кандидатською дисертацією, було проведено дослідження збігання чи не збігання кордонів агроекосистем. Вони є економічні кордони, природні. Якщо вони не збігаються, то баланс гумусу в ґрунтах тих господарств, які там знаходяться, він прагне до від'ємного. Якщо вони, ці кордони близькі до збігання, баланс гумусу прагне до одиниці, ну тобто до вирівнювання, скажімо так. Власне, от в цьому полягає і наше намагання внести часову компоненту у традиційну просторову парадигму географії.
Дякую.
Thank you, and we have one more question. Victoria Patyuk, please.
Дякую за таке фундаментальне дослідження. Ну і хотілося все ж таки у вас запитати, як в такого гуру філософсько-географічних досліджень. От до 2022 року, на мою думку, сталий розвиток – це була концепція, яка була актуальною для будь-якого географічного простору, незалежності від того, чи це країна, чи це певні ландшафти. Тепер, після 2022 року, в нас в Україні сформувалася ціла низка прифронтових, дуже постраждавших територій. На якому парадигмальному рівні має відбуватися їх розвиток і які саме аспекти концепції сталого розвитку для них будуть в подальшому актуальними?
Я зрозумів ваше запитання. Моя відповідь може вам здатись трошки незвичною. Я нещодавно відповідав на подібне запитання журналу «Довкілля України», де я позначив, що зруйнування наших міст, це дуже боляче звучить, це сприймати боляче, це людські долі, це знищення життя і так далі. Але, от, наприклад, з точки зору розвитку сільського господарства, а там було таке запитання, так, вони заміновані, але певною мірою ґрунти відпочивають. Враховуючи надвисоку інтенсивність, передвоєнні роки і це пов'язано з ринковою економікою, експлуатації наших родючих земель, вони вже давно потребують відпочинку. Таке уявлення, як чистий пар, ну, для відпочинку землі, воно вже у фермерів непопулярне, ну, років 25-30. Це перше. Друге. Розумієте, якусь конкретну парадигму для відбудови і для внесення у якісь тренди світові чи загальноукраїнські порушених земель знайти дуже важко. Скажу одне, якщо брати до уваги якісь світові напрацювання, ну, можливо, це великі хвилі Кондратєва, де поступово, поетапно відбувається розвиток окремих територій. От є такий український філософ Костянтин Віталійович Корсак, з яким ми часто спілкуємося, співпрацюємо, пишемо спільні роботи. У нього є своя концепція виробничо-технологічних укладів. У свого розвитку. Тобто він поступово еволюційно все-таки змінюється. На місце індустріалізації приходить інформаційне суспільство, там якісь спеціальні зони розвитку новітніх технологій. Але, повторюю, на жаль, у нас зміна ця відбулася не еволюційно, а революційно, отак катастрофічно завдяки воєнним діям, завдяки агресії нашого північного сусіда. Дякую.
Дякуємо.
Okay, thank you. And we have one more, the last question. Irina Varfolomeeva, you're welcome.
Добрий день, Сергій Петрович. Дуже приємно вас бачити на такому зібранні. Сергій Петрович, ну, продовження, мабуть, попереднього питання. А скажіть, будь ласка, досвід яких країн, мабуть, потрібно було б прислухатися, познайомитись нашій державі, враховуючи той факт, що нам доведеться об'єднувати і побудову постіндустріального і інформаційного суспільства, і повоєнну відбудову. Кого б ви рекомендували нам?
Ви знаєте, що недавно Київський університет проводив конференцію, де була пані Вікторія, я слухав її доповідь. Якраз вона стосувалася, її проблематика от того питання, що ви задали. Я там робив свою доповідь і в якості прикладу навів Швейцарію. Що там у нас? Шоколад, медицина, ну і так, і адронний колайдер, перепрошую. Так ось найкрупніше місто Швейцарії, ну десь в районі там 250 тисяч. Ось вам відповідь на це запитання. І це не заважає їм розвивати високі технології, бути в перших рядах. При тому, що здатних до освоєння земель, а там же ж гори, ми ж знаємо. В країні дуже мало, в Україні їх дуже багато. І я додаю до свого попереднього запитання на доповідь наших колег із університету Бекетова. Дезурбанізація. Оце в найближчі 15-20 років це концептуальне рішення багатьох проблем. В тому числі і загрози з півночі постійної, яка не спаде. Вона трошки може заморозитися, але вона постійно буде. Або, перепрошую, пускати ракети на велике місто, або розосереджені поселення. Де сенс таких обстрілів? Він пропадає. Дякую.
Дякую, велике запитання.
So thank you for questions and answers. And we are moving to the next speaker. And the topic of presentation is optimized fuel values for emission reduction. And the speaker is Andres Walter, Faculty of Business, Computing and Law, Technical University of Applied Sciences, Wildow, Germany, Department of Industrial Engineering, University Tor Vergata, Italy.
Welcome everybody. I hope you're doing well. My name is Andreas. I will give you a short presentation on my research, optimized fuel values for emission reduction. I'm a PhD student at the University Tor Vergata in Rome, and this is in cooperation with the Technical University of Applied Science in Wildau, and my two scientific supervisors are Professor Rocco and Professor Kubica. So we're talking about emission reductions, emission reduction due to optimized fuel values. And to give you a background on myself, I'm working as a flight operations inspector in the German Civil Aviation Authority. And I'm an engineer and also a pilot. The structure of my presentation today, I will give you the introduction and some motivational background. And we are talking about the research process and this paper, and I'll give you a short outlook on further steps. So the background or the motivation on this paper and on my research work, aviation is growing. In 2022, aviation was almost back to the pre-COVID levels, and predicted passenger numbers are rising and rising. And this high traffic volume is connected to a high demand of aviation fuel, since most of the aircraft nowadays are still combustion driven. And as a result of the internal combustions, you have different emissions, mostly known as carbon dioxide and water, but you have also other emission results. This fact is known, and manufacturers have introduced new aircraft types over the last year with some fuel-saving benefits. You can see in the table on the right-hand side, but the fuel-saving effects are outweighed by the increase in the amount of aircraft and the amount of travel. And since reducing the effect of global warming have become a goal, further steps are needed to reduce emissions. So as I told you, the emissions are one driver to reduce the fuel consumption. And the second large driver, mainly on the operator side, is the amount of cost you need to spend on fuel. It's around 1/3, depending on the fuel cost of the total cost. The share is 1/3 you have to spend for fuel. So airlines are interested in reducing fuel consumption just to save money. And one way to reduce the amount of consumed fuel is to reduce the weight of the aircraft. And this is due to the physics of flight. You can see on the right-hand side, you have to create some lift, or you have to create lift to overcome the weight. And this is done via the thrust of the engines, and on the other end, that will produce drag. So in cruise flight, for example, all forces are balanced, and if you reduce the weight, you need less lift, and therefore you need less thrust and will create less drag. And if you add some extra weight, you need extra fuel. This is called the fuel penalty factor. So for 100 kilogram of additional weight carried for a sector, you need around 3 to 5 kilogram fuel per hour as additional consumption. On the other hand, if you can reduce your weight by 100 kilogram, you will save some fuel. In my research, I focused on freight aircraft, and they are flying an average of around 16 hours per day. So it's quite a lot, and therefore the effects of the fuel penalty factor or the fuel saving factor are accordingly good. Overall, in aviation, you have a high safety level. The likelihood of an accident has to be quite remote, and this safety level has to be assured all the time. On this slide, I show you one example of fuel-saving benefits. Even if it's the other way around, it was conducted via extra fuel or additional fuel. In the second to last row and in the middle column, you can see an additional fuel of 700 kilograms. This is the amount of fuel you need for 5 minutes on the aircraft I researched. It's the Boeing 777. And as a result, you can see this 700 kilogram translate to an additional consumption of more than 350 kilograms for this flight sector, Hong Kong to Cincinnati. So if you could reduce the amount of fuel by 5 minutes, you would save 350 kilograms and even more. Because this calculation is conservative, not every fuel portions were reduced accordingly. So this was some information on the motivation and an introduction, and now we are talking about the research process. The research, as I mentioned, was done in close cooperation with a cargo aircraft operating airline, and they provided flight data, and it was a statistical evaluation conducted via the use of Excel and MATLAB, and quite recently I started to use a third program called YASP. In the first step, I did an overall evaluation of a 5-year period, and I got the information of around 40,000 flights. And in the second step, I did a deeper evaluation of special flights with high payload and long flight times. And this period contained around 14,000 flights. And the increase in flights per year was due to the increasing of the fleet over the years. So the airline started with 8 aircraft, and now they are around 20 aircraft. They're operating around 20 aircraft. In the course of my research, the aviation regulation also changed. And in Europe now we have so-called performance-based regulation in the area of fuel. And that means that you are allowed to introduce a performance-based approach, and for that, you have to evaluate some safety performance indicator, for example, consumption of the contingency fuel or the difference between planned and consumed fuel, and the amount of diversions, and so on. So in the figure on the right-hand side, you can see the evaluation for one fuel portion, which is the alternate fuel. And in this paper I will focus on the alternate fuel. You can see on the right-hand side the alternate fuel planning, which needs as one portion the missed approach track. And the chart on the right-hand side shows you the instrument approach chart for Leipzig Airport. And in case you cannot conduct the landing in the first try, you have to conduct a missed approach and fly the green highlighted track back to the start of the approach point. And with the introduction of the new performance-based regulations and based on performance indicators, you might be allowed to reduce the fuel needed for this track. And that would reduce the carried weight for the sector. All of that has to be done in a performance-based environment, and yeah, you can see two figures showing the areas of tension in the practical implementation of new safety-driven regulations. You are in the area of tension between bankruptcy and a catastrophic accident. So that means the investment on safety, if you invest too much, you might go bankrupt, and if you invest too less, it might be too less, ending in a catastrophe. And on the right-hand side, you can see the concept of the practical drift, which means you have a baseline performance, but operational environment, you will rarely meet your baseline performance, and therefore you need some protecting barriers. And one of these barriers is your safety performance indicators. And as I mentioned, I did a statistical evaluation to compare the planning and conducting of the flights with some of these already mentioned performance indicators. And as a result, I found out that the planning and the conducting of the flights is very reliable, and performance indicators such as the diversion rate are fulfilled. So it would be possible to reduce the alternate fuel by 5 minutes, and therefore it would be possible to save fuel. And as a result, for the researched fleet of 20 aircraft, the amount of saved fuel per year would be around 2 million kilograms, and therefore the carbon dioxide emissions reduced. Carbon dioxide emissions would be around 6 million kilograms. That would be a new standard. I also found out some additional optimization points, for example, the pilot in command extra fuel, as you can see on the right-hand side. On average, there were around 900 kilograms of extra fuel. The operator might think about reducing this pilot in command extra fuel also. So this was a short overlook on the process and what is the outlook. My proposal on reducing the alternate fuel is a starting point for further evaluation. If you have better data, if you have more data, if you have more information, you might figure out more customized and better information, and therefore might plan or might introduce even better performance-based or the performance-based approach. So you might customize the fuel scheme for your operation. Therefore, further research is needed on safety and performance indicator. And you might start to introduce external factors like the weather and the airport even more, and try to reduce the consumption based on this information also. But in the end, it's one step to reduce the emission and to make aviation a bit more climate neutral. So I finished my presentation, and thank you for your contribution, and I'm open for questions now.
Thank you a lot for such an interesting presentation, and we are ready to ask some questions. Mr. Nazimko, you're welcome.
What does stand behind the penalty? High taxes? Вроде включено. No answer.
Could you please
No reaction.
Sorry, what was the question exactly? I couldn't understand well enough.
What does stand behind the penalty? High taxes?
Okay. Okay. The fuel planning, I started with the idea, around 5 years ago, to reduce the final reserve fuel. Final reserve fuel is 30 minutes. You always have to carry, and it's a portion of the fuel you never use, never. And if you might touch the final reserve fuel, you have to declare an emergency. So you land always with 30 minutes, or most of the time even more. So practical wise, you have fuel for 1 hour when we finish our flight. So I thought, why not reduce this amount of fuel? And as I have shown in the presentation, if you reduce the amount of fuel, you reduce the weight, and quite drastically you reduce the emissions. And this is a novel approach, not to reduce the weight. This is known. The manufacturers starting to use composites and carbon fiber, lighter materials, and so on and so on. But this special portion of the fuel, this is new. And for that, I started to evaluate the statistics of the company. And one result was the alternate fuel planning, which this was not my intention to evaluate this, but it might be possible as one of my results to also reduce the alternate fuel. Still, as a result of my overall thesis, this is part of my PhD thesis, I will suggest to reduce the final reserve fuel. So that is the result of my overall thesis. But in this paper, I'm presenting ways to reduce another portion, which is the alternate fuel.
I see. Thank you.
Okay, thank you for your questions and your answers. And we are moving to the next cycle of presentations, which are about sustainable transportation. And the word is given to Alona Slovska from Ukrainian State University of Railway Transport. And the presentation is called Research into the Travelness Loading of the Container with Sandwich Panel Walls when Transported by Rail. Does anybody hear something? Okay, there are some problems and we can't hear the presentation. The author could please turn on the microphone. We don't hear the presentation at all. Ми зовсім не чуємо презентацію.
Вибачте, будь ласка, а чи немає у вас резервної версії презентації? Чомусь за технічних причин звука не чутно.
Тому що включив автор і включив ведучий.
Автор має виключити, має презентація лише у ведучого. Будь ласка, вимкніть мікрофони, вимкніть презентації у себе на комп'ютерах.
Дякую.
Ось ще включена презентація. Будь ласка, вимкніть. Все, дякую.
Dear conference participants, I would like to present the research prepared by the authors Gleba Tulia, Alena Lovska and Evgen Krasnokursky, and which is entitled as following. Research into the transverse loading of the container with sandwich panels walls when transported by rail. The efficient performance of the machine building industry requires development and putting into operation model structure of vehicles. For a long time, rail transport has been the most competitive industry of machine engineering, which accounts for a large proportion of transportation of freight. The experience of development of wagons fleet in the UIC member countries indicates a steady trend in improving the level of traffic safety, which ensures operational reliability and environmental compatibility of vehicles. At the same time, modular vehicles or transport means, in particular containers, are one of the most optimal solutions to achieve these requirements. Except of advantages of these transport means, there are also significant disadvantages associated with insufficient strength of their structures. The main reason is the significant operational loads, including dynamic sign variable ones affecting the vehicles. These loads affect not only the container, but also the freight stored inside. Due to the fact that this freight has own degree of freedom, the container structure can have additional loading, and this loading can damage the container. This requires additional maintenance costs. Moreover, it can also affect the traffic safety and it can cause ecological problems. One of possible solution of the described problem can be an application of sandwich panels as components of container sidewalls to ensure their needed strength. The sandwich panels are composed of two metal sheets. Energy-absorbing material is placed between them. Such a solution can improve the strength of the container while reducing their weight. Their calculations were carried out to determine the thickness of the cover sheet of the container. The cover sheets for each section were considered as a thin walled slabs with a width of 6.58 meters and the height of 2.591 meters. The sheet thickness was determined by the formula which is given in this slide. Based on the calculation, it was determined that the stress is of 210 megapascals, which corresponds to the Young modulus, and Poisson ratio was 0.28. The value of the transverse force was 0.6, where Pk is the carrying capacity of the container and the volume delta is of 1.6 millimeters. Taking into account these facts, the thickness of the energy-absorbing layer can be considered with the volume of 32.8 millimeters based on the condition of maintaining the wall size within a typical container. Mathematical modeling of its dynamic loading was carried out in order to substantiate the use of sandwich panels in the sidewalls of the container. It was performed for a container placed on a flat wagon under side rolling oscillations. The calculation scheme is shown in figure left up. The derived mathematical model is written right up, marked as equation 3. The mathematical model was solved in the MATCAD software for the zero initial conditions. The model was reduced to the normal Cauchy form with a subsequent solution according to the Runge-Kutta method. Based on the calculation, it was found that the maximum accelerations to the container is of 1.7 meter per square seconds. The volume of acceleration obtained was almost 5% lower than the acceleration acting to a container with a typical design. The calculation was made at the stiffness coefficient of the energy absorbing material of 1.5 kilonewton per meter and the viscose resistance coefficient of 2 kilonewton secunda per meter. These parameters were determined by a subsequent section, and it was identified that the accelerations were within the permissible values. The resulting accelerations values were included in the strength calculation of the container. The spatial model of the container was built in the SolidWorks software, as we can see in figure left up. It included the structural elements rigidly interacting with each other. The strength calculation was performed by means of the finite element method in the SolidWorks software. The criterion of von Mises was used in the calculation and as the calculation criterion. The viscoelastic connection in the sandwich panels that form the side walls was included as the spring damper connection by means of the software complex options. The design diagram of the container included the loads, which is shown in figure left down, and which are as following. The vertical static force PV applied to the lateral beams, and transverse force PT applied perpendicularly to the said wall. The transverse loads included the pressure from the freight as well as the dynamic loads. The dynamic loading was applied from the container slope side. The pressure from the freight to the container walls was determined with the Coulomb method using a Sinelnikov adjustment. The finite element mesh of the container was created from spatial tetrahedrons. The model consisted of 11 million or more over 11 million elements and almost 308,000 nodes. The maximum element size was of 80 millimeters and the minimal element size was of 16 millimeters. The boundary conditions within the definition of degree of freedom was defined in the fittings. The material properties of steel not 9C2Cu were prescribed. The results of the calculation are depicted in these figures. The maximum stresses were identified in the contact areas between the bottom side rail and the fitting stops about 180 megapascals. This is shown in figure left down. The resulting stresses were lower of 6% in comparison with a typical container design. Maximum deflections were found out in the middle of the outer wall of the container with the volume almost of 4 millimeters. Further, the values of accelerations acting on the container were determined. The results were obtained to test the mathematical model presented 2 slides above. In this case, the F criterion was used. The results of the calculation allows us to conclude that the hypothesis of adequacy is not rejected. To summarize just briefly, it was chosen the container walls with the sheet thickness of 1.6 millimeters and the filling with the thickness of 32.8 millimeters. The strength calculations revealed that the maximum stresses occurred in the contact area are of 180 megapascals. Thank you for your attention.
So if you have any questions, you may ask them. Okay, so if no one has questions, I have. Sorry, Mr. Nazimko, you're welcome.
Thank you. Angle of internal friction. Це стосується якого матеріалу? Наповнювач, сендвіч, що за сендвіч тут зараз? Поясніть там.
Дякую за запитання. Сендвіч-панель утворюється двома металевими, а саме сталевими листами, низьколегована сталь 09Г2С, між якими знаходиться наповнювач. Ну, в якості прикладу ми взяли піноалюміній як один з найбільш поширених типів енергопоглинальних матеріалів.
Ще раз напомню, що за алюміній? Ще раз право напомню.
Піноалюміній.
Піноалюміній. Його кут внутрішнього тертя, так?
Ну, у якості прикладу взяли саме його.
Кут внутрішнього тертя піноалюміній, так?
Да, вибачте.
Дякую.
So the sandwich panel consists of two metal sheets.
Питання можна?
Yes.
Пані Альона, наш народ дуже великий. І ми знаємо, що крім отих містечок модульних, які будуються зараз для переселенців, уже давно використовують контейнери для житлового будівництва, скажімо так, таке імпровізоване житло. Ви у своїх дослідженнях не передбачали таку можливість використання їх там, і в зв'язку з цим, можливо, ви туди заклали чи закладете з часом якісь екологічні вимоги? Дякую.
Дякую за запитання. Досить цікава пропозиція. Однак ми в рамках транспортної галузі виконували дослідження, тому розглядали питання саме перевезення залізницею. На даний час питання будівництва з контейнерів житлових якихось приміщення ні, цьому ми питання не приділяли.
So the question was about usage of sandwich panels for building model towns. And the answer was that the usage of these containers was based, not like based, it was research only in terms of usage it in railway stations. And that's it. Okay, and let's move to the next speaker. The next speaker is Vasil Ravlyuk from Ukrainian State University of Railway Transport, and the topic of presentation is determination of the thermal stress state for the composite brake pad of a wagon at operational loads.
Доброго дня. Якщо можна, включіть, будь ласка, презентацію. Дякую.
Dear conference participants, I would like to present the research with the title Determination of the thermal stress state for the composite brake pad of a wagon at operational loads. The rapid development of the rail industry is accompanied by an increase of the train speed and the axle load, the need to improve the structures and materials for the rail vehicles, increase in the tare-load ratio of rail vehicles, and so on. In this regard, friction materials used in the railway industry, in particular for braking system, should provide a fixed friction coefficient and low wear at various operational and environmental conditions like speed, temperature, pressure, noise, extreme weather, and so on. The violation of the operational requirements causes an increased wear of brake pads, and therefore in operation brake pads can be used for braking. This certainly leads to damage of the rolling surfaces of the wheels and directly affects the train traffic safety. Therefore, in order to prevent abnormal wears of brake pads, including dual wedged shaped wear, it is advisable to develop requirements and devices that will ensure the uniform wear of brake pads so that they can serve during the whole repair-to-repair period at depots. This makes it possible to dispose of such brake pads with a mirror portion of the working composite mass remaining and a lot of costs during operational and maintenance Ukrainian railways or industrial enterprises with their own freight rail vehicles, so that they will purchase brake pads and significantly reduce operational costs. Currently, the entire fleet of rail wagons is equipped with devices for uniform wheel wear of brake pads, but they have very low reliability. Because of this, their efficiency is lost even in those wagons that are just being put into operational from wagon building or repair enterprises. Therefore, it can be seen from the histogram that more than 90% of freight wagons work with wedge dual wear of brake pads, and almost 5% have brake pad cracks behind the temperature notch. Because of this, the braking efficiency of freight trains is deteriorated. The objective of the research was to determine the thermal stress state of the composite brake pad used for a wagon at operational loads. To achieve this objective, the following tasks were set: to investigate the thermal stress state of the composite brake pad with the rated parameters, and to investigate the thermal stress state of the composite brake pad with dual wedge-shaped wear. The thermal stress state of the brake pad at operational load modes was determined using the strength calculation. It was carried out with the finite element method in SolidWorks software. Composite brake pad 2TP11 was chosen as the prototype. The main characteristics of the pad are given in Table 1. The spatial model of the pad was built in SolidWorks software, as we can see in figure left. The finite element model of the pad was built with spatial isoparametric tetrahedrons with 4 Jacobian points. The optimal number of elements of the model was determined by the graphoanalytic method. The measure was based on the curvature. The number of elements was over 2,800 and number of nodes was over 12,200. The model was fixed by the back plate in the area adjacent to the shoe. The material of the pad was composite with linear elastic orthotropic properties. At the same time, the compressive strength of the material was taken equal to 15 megapascals and the tensile strength was taken close to 0. The design diagram of the pad is shown in figure left. It included the horizontal load PH to the working part of the pad, the value of which was taken according to the operational mode of the air distributor, 41.69 freight mode, 34.34 medium mode, and 17.5 for empty mode. It should be noted that the pad suffered temperature load during braking. The temperature on the rolling surface of the impeller can be determined by the analytical expression given on. By analyzing the dependencies 1, 2, 4, we can conclude that the temperature on the pad surface was constantly changing by braking time. Therefore, when calculating the strength of the pad, the maximum available value of the temperature load PT was taken into account. This load was applied to the working surface of the pad and was taken equal to 400 degrees Celsius degrees. Since the material mentioned had a small tensile strength and no yield strength, the strength calculation was made according to Moore-Coulomb criterion. It means the theory of internal friction. It is known that this criterion predicts failures when the simultaneous action of the maximum principal tensile stress and the minimum principal compression stress exceeds the appropriate stress limits. On slides 7 and 8 are shown results of the calculations. The figure left shows the first principal stress that occurs in the block, and the second and third principal stresses are shown in this slide. The analysis of achieved results allows to conclude that the maximum stresses occur in the upper part of the pad in the area of interaction of the backrests with the sidewall, and the value was of 14.9 megapascals, which does not exceed the permissible value of 15 megapascals. The work also carried research into the thermal stress state of the composite brake pad with a dual wedge shaped wear. The strength of the brake pad was calculated and its dual wedge shaped wear was taken into account. The calculation was made for the composite brake pad with a dual wedge shaped wear used for the wagon with a mileage of 63,400 kilometers. According to the measurements, the ped had the following abnormal wear characteristics: thickness at the upper end of 10 millimeters, thickness along the borderline of the plates 27 millimeters, and thickness at the bottom end of 20 millimeters, and length of harmful abrasion at the top of the ped of 85 millimeters. We can see this in this figure. The mass of the composite brake ped with wear was 1.98 kilograms. It was determined using the SolidWorks simulation calculation program. The resulting mass was 39% lower than the mass of a typical ped with the rated dimensions. Figure left shows the calculation diagram of the ped with wear, as well as, on the right side, the diagram of temperature load application. When drawing up the calculation scheme of the pads, the identical loads for the pads with nominal values were taken into account. The finite element model of the brake pad with wear consists of 5,429 elements and 24,502 nodes. The maximum element size of the mesh was 12 millimeters, and the minimal element size was 2.3 millimeters. The results of calculations are shown on slides 11 and 12. Here you can see results of the ped from the simulation analysis. Figure right depicts that the maximum stresses occurred in the back of the brake ped, and the value is of 80.7 megapascals, which exceeds the permissible value of 19.8%. This graph shows the stress distribution along the edge of the upper part of the brake ped. At the same time, stresses on the graph are represented by the module. To determine their numerical values, the probing option in simulation software was used. From this graph, it can be concluded that the maximum stresses occurred at the height of 135 to 140 millimeters from the top of the ped. I would conclude that the maximum stress distribution in the ped can be explained by the fact that the frictional force is taken as upward calculation. The maximum stresses occur in the backplate of the ped with the value of 18.7 megapascals, and other findings are concluded in this text. Thank you for your attention.
Okay, thank you for your presentation. And if somebody has any questions, you may ask them. So we have a question from the chat from Svetlana Mantulenko. Have the results of your research been implemented in practice? Did the predicted results match the practical ones?
Дякую за запитання. З вашого дозволу, я є одним зі співавторів даної доповіді, і з вашого дозволу я відповім на це запитання. Дані дослідження наразі мають тільки теоретичне підґрунтя. Саме є математична модель, яка підтверджена комп'ютерним моделюванням. У майбутньому ми плануємо проведення експериментальних досліджень шляхом використання термодатчиків, які можуть бути встановлені в колодку і таким чином які можуть підтвердити ті результати, які ми отримали наразі. Дякую.
So currently the results have only a theoretical basis, but in future there is a plan to conduct experimental research. And we have one more question from Mr. Nazinko. You're welcome.
Дякую. Дуже незвичний результат. Зношення таке локальне. Чим це можна пояснити, коли не зношення тільки з одного кінця? Розподілом температури, напружень. Може це недосконалість конструкції самої колодки при придавленні до притиснення до колеса?
Дякую за запитання. Так, мене чути. Значить, це дійсно, як ви сказали, це через недосконалість конструкції гальмової важільної передачі в вантажних вагонах відбувається отаке клинодуальне зношення в експлуатації. І як там видно, саме 90% колодок вони зношуються клинодуально. Тобто ось у нас така ситуація. І якщо підрахувати, знаєте, витрати від всіх оцих експлуатаційні витрати, це величезні сотні тисяч гривень, а то і євро можна. Да, от.
Михайло точно, це що, монополія, да? Монополія інституту, хто це зробив, чи що? Чому нема конкурсу зробити такі, як слід? Ну, монополісти, мабуть, проєктували, так чи ж? Я.
Питання не зрозумів, можете повторити, я що то?
Причина цього недосконалості – монополізм інституту, який проєктував, відомчий, чи що? Може конкурс появитися? Це явний ляп.
Причина недосконалості конструкції, я сказав, гальмової важільної передачі, те, що в центр ваги тяжіння знаходиться не в потрібному місці на даний час. Ми проводимо дослідження для того, щоб удосконалити. Ми вже провели дослідження з метою модернізації елементів гальмової важільної передачі і перенести безпосередньо отвір у елементах конструкції.
А може хтось зацікавлений в тому, щоб його це рішення залишило? Наприклад, монопольний інститут, проєктант, ні?
Монопольний інститут. У нас дослідження проводяться на рівні залізниці. Наш пристрій зараз використовується на 12 вагонах дослідних, які експлуатуються вже. Вони пройшли безпосередньо і деповський вид ремонту, капітальний вид ремонту. Тому наш пристрій зарекомендував себе з позитивної сторони, але є різні питання з Укрзалізницею.
Let me please translate.
Монополія.
So the question was, how could you explain such a strange result? And the answer was because of the construction. And the reason of imperfection of this construction is now under the experimental research. So sooner there will be some more theoretical basis. And now we are moving to the next presentation. And the author is Eman Shekhenov from Sadbayev University, Kazakhstan. And the topic of presentation is energy potential of mining transport at mines of Kazakhstan located at high altitude.
Dear ladies and gentlemen, dear chairman, my name is Eman Shekhenov. I'm representing Sadbayev University, Almaty, Kazakhstan. Today I would like to represent the result of our studies, energy potential of mining transport at mines of Kyrgyzstan located at high altitude. Kyrgyzstan is Central Asian country located in territory of nearly 200,000 square kilometers, 7 million population, and 45% of all glaciers in Central Asia are situated in territory of Kyrgyzstan. They are major source of water supply in rivers, and the forecast of their condition are particular concern due to effect of climate change. Kyrgyzstan covered 90% of their territory with mountains, has a beautiful nature, and sustainable mining is important part of future development. Gold mining is one of the major industry in Kyrgyzstan. More than 55% of export is gold. 17 deposits are registered in Kyrgyzstan, more to be discovered. More than 1,000 tons of golden ore deposits, golden ore, gold is registered as a resource. Many mines are located at altitude of 3,000 meters, and the transportation of golden ore from that mines to processing plant is of great importance for mining companies. If you look at the technologies nowadays, mining companies are focused to develop to reduce their carbon emission. Trolley assist any mines located with 150-meter depth can be seriously considered for trolley assist application for existing big mining trucks. This technology can help mining companies to reduce CO2 emission 20 to 60%. Another promising technology which is coming, it is hybrid power packs for mining trucks, which according Rolls-Royce engineers can reduce carbon emissions for factory installed systems up to 29% for efficient recuperation of energy. For example, for downhill empty going trucks is 22%, downhill loaded trucks is 54%, which is quite impressive. Aerial ropeway, it's a technology which can be widely used for mining operation in mountain condition in Europe. This is why, because system has very small footprint on the ground and produce less noise and dust, which will be very beneficial for local ecosystems. So looking for performance of aerial ropeway in Çaratepe copper mine in Turkey, we see that specific fuel consumption is just only 0.6 liter per ton, whereas in conventional trucks, it's up to 2 liter per ton, which is 3 times more than aerial ropeways. Of course, aerial ropeway application should be individually in details considered for every individual mine, because resistance factor of the wagon movement of the whole rope is individual for every mine. Potential energy on Gero and Jamgar mine site is studied on our article described there. Please read it. These two mine sites are relatively new developed mine sites and has potential for recuperate energy because they transporting ore from up to down. So Gero mine site transporting every year 1.3 million tons golden ore to a vertical fall of 1,088 meters. So it can potentially, it has potential of 13 million megajoule of energy. So when we convert it to megawatts, is 3,800 megawatt hours per year. And Jamgar mine is potentially can be considered for recuperation 370,000 megajoules, which is 103 megawatt hours per year. Performance of diesel engine driven on-highway trucks on high altitude. We studied this application. We demonstrated in our article cycle time results for trucks with 25 ton payload for 35 kilometer distance, consuming 50 liters of fuel every trip, which make a production of 9 ton per hour. So specific fuel consumption is a 2 liter ton per kilometer, which is significantly higher than specific fuel consumption for aerial ropeway. So when we come for recuperation opportunity, we studied Stallman patent registered 10 years ago in World Intellectual Property Organization. It has 2 lines for winding device. Energy can come through conductor 13, which regulating energy flow. When winding device for aerial ropeway transporting wagon loaded downhill, so it can opportunity to generate the electricity, which can be connected to system with clutch 5 through alternator 8, and the energy can be stored in fuel cells. And when energy needed, so conductor 13 can redirect the electrical energy through electric motor, which can do job 6 electric winch to lift the cargo up. So fuel cells can be different configuration. In nowadays, lithium battery capacity and availability makes it feasible. It's widely used in hybrid electric trucks, in mining industry even, and in civil industry, as you know. And the recycling of lithium battery is a great meaning for sustainable resource saving initiative. So nowadays there are technology to recycle more than 90% of cobalt, for example. So the industry going in that direction. As a summary, I would like to mention that analysis of operational performance of aerial roadway and diesel dump truck showing more than 3 times more energy efficiency, and the transport path of aerial roadway more than 3 times shorter than compared with road construction for dump trucks, and the considering amount of renewable energy share in electricity generation in Kyrgyzstan, aerial roadway can be significant contribution for environment and local ecosystems. Thank you for your attention. Дякую. We as authors are very grateful for management of Cheroy and the Chamgar Mine for openness and cooperation, and for cooperation and support of Kyrgyz Mining and Metallurgical University for their support and contribution for this study. Thank you. Goodbye.
Okay, thank you for your presentation. Colleagues, do you have any questions? Okay, so tell us, please, does your idea have any practical implements? And do you plan to implement it in future? Tell us, please, does your idea have any practical implementation? And do you plan to implement it in future? We don't hear you.
Hear me now?
Yes, now we can hear you. Unfortunately, we don't hear you at all. Maybe we could write our question in chat and you will answer it in chat too. Because we don't hear you at all. So the next speaker is Olena Boyarchuk from Luhansk Taras Shevchenko National University, Lubny, Ukraine. And the topic of presentation is pathophysiological mechanisms of adaptation of the mucosa of the gastric cardia to portal hypertension.
Good afternoon, everyone. My name is Olena Boyarchuk. I am a candidate of biological science, associate professor, head of Department of Anatomy, Physiology, Human and Animals, Luhansk Taras Shevchenko National University, Poltava region, Ukraine. Title of my presentation: Pathophysiological Mechanisms of Adaptation of the Mucosa of the Gastric Cardia to Portal Hypertension.
In economically developed countries, cirrhosis of the liver is one of the 6 main causes of death in patients aged 35 to 60 years. Geographic features of mortality from cirrhosis among men and women are similar. Significant geographic differences in the incidence and mortality of liver cirrhosis are observed in developing and developed regions of the world. This is due to the different level of the economy and the development of medicine. One of the goals of sustainable development in Ukraine is good health and well-being to ensure healthy lifestyles and promote well-being for all, regardless of age. To solve this goal, one of the tasks is to reduce the premature mortality of the population by a quarter, including through the introduction of innovation approaches to the diagnosis of disease. Therefore, the actuality for clinical and experimental researches of etiopathogenetic mechanisms of development and elimination of liver disease and their complications very important. The famous methods of modeling of before and intrahepatic blockage of the portal system have low reproduction. It is not possible to do it in a small laboratory animals. It has some technical difficulties and low economic effect and high mortality rates in laboratory animals. Therefore, the purpose of the research includes to elaborate some effective, easy reproductive model of before and intrahepatic blockage of the portal system, and to study pathophysiological mechanism of adaptation of the mucosa of the gastric cardia to portal hypertension in experiment at rats. Results of the research allow to constant that is necessary to create the complex effect for reliable modeling of the liver cirrhosis. The research was carried out in Wistar rats. Intrahepatic portal blockage was modeled by intraperitoneal injection of chloroform 2 times a week. Before hepatic portal blockage was modeled by injection of warm glycerinum from the 20th day after the beginning of the chloroform injection. Modeling of before hepatic blockage of the portal system after development of toxic liver dystrophy lead to formation of the liver cirrhosis with the stable portal hypertension. Demonstrates with the signs of hyperplastic and atrophy process of the mucosa, formation of erosion, inflammatory infiltration of intermediate tissue, and rebuilding of the glandule were the basis of morphological changes of gastric mucosa in rats with the experimental before and intrahepatic portal blockage, and your experimental model did not lead to the death of experimental animals. The proposed model of before and intrahepatic blockade of the portal system needs clinical and experimental study in the future. Thank you for attention.
Okay, thank you for your presentation. However, we are sorry to tell you, but the speakers have already informed us that they have technical problems and unfortunately cannot join us. So if you have any questions, you can ask them writing on email. And thank you for taking part in our conference today. We look forward for further cooperation. Stay safe and goodbye.